Good morning. This is so bright. We are back for day 2 of PromCon. Everybody had a good night's sleep in between. I definitely had after yesterday. How did you like the social event? Everybody had a wonderful evening? All right. You need to be louder because Jia is outside. She needs to hear it. All right. That was about right. Yeah, we are going to start day 2 with Philip and Pedro, who is virtually joining as a recording, I guess. We still have probably slots for lightning talks. You can still sign up in the front at the registration desk. Otherwise, it's pretty much the same. We'll have the lightning talks at the end of the day. And I'll let you know if there's more in between. I can't think of anything right now. But I'm really looking forward to your talk now. Take it away.
Thank you. All right. Hello, everyone. So my name is Philip. Pedro was supposed to be in person here. Unfortunately, he couldn't make it. And a lot of the work that we're going to present, he actually did a bunch of it, the bulk of it. So we've decided to make this a hybrid presentation where Pedro's part is pre-recorded. We're going to play that in the first part, and then I'll do the second part like live in person. Before we get started, I'll just briefly introduce both of us. So my name is Philip, as I said. I am a production engineer at Shopify, where I work with Pedro on the metrics team, and we handle everything from kind of metric collection to ingestion, alerting, dashboarding, all of that stuff. Also, I'm currently helping maintain the Thanos project, and in the past, I've also been involved in Kube State Metrics and Prometheus Operator. Pedro, he's obviously not here. He is originally from Brazil, and he's currently mostly involved in the Kedar project. So what we'll talk about today is very closely related to what you heard about OTel and push-based and Delta yesterday. We'll briefly talk about how applications are instrumented at Shopify, and spoiler alert, we still use statsd. We'll briefly explain the statsd protocol. Maybe just a quick show of hands. How many people here have heard of or use statsd? Wow, okay. So yeah, this will be very relevant for you. And finally, we'll kind of explain how we've I would say, successfully managed to merge these two worlds of push-based deltas with pull-based absolute value scrapes. So at this point, I think I'm going to kind of hand it off to virtual Pedro to do the first part.
Hello everyone, I hope you're having an amazing PromCon so far. Before I get started and talk about the solution we adopted for custom metrics at Shopify, it's important to understand how we work and how our developers interact with infrastructure at the company. At Shopify, we have a long history with Ruby and Rails. We also have one of the biggest Ruby apps written and deployed in production, which is our monolith with over millions of lines of code. We also use Ruby as default for all of our product development, and apart from that, we use Golang and Rust for systems as system programming languages. We also have an in-house application platform where developers, they don't need to think about Kubernetes resources, but rather they think about what their application needs to work properly, like one web server, one job worker, and the application platform will take care of deploying the underlying Kubernetes resources. The journey towards the solution we are presenting today started for my team when we began a migration from a vendor solution towards a Prometheus-based observability stack. At that moment, the applications were using statsd as default for metrics instrumentation, and we even started looking into migrating those apps to use Prometheus-based instrumentation, but we had this huge code base already instrumented with statsd, and we also saw that Ruby lacked a good implementation of Prometheus native instrumentation. We also had some short-lived workloads, which poses a challenge for the pull-based approach that Prometheus uses, such as machine learning jobs and even short-lived job workers. So we decided to use the statsd exporter. Using the statsd exporter, you can convert metrics in the statsd format into a Prometheus native representation. We also are deploying the statsd exporter outside of the application, so developers don't need to think about this extra piece of infrastructure touching their applications. And we allow users to configure the metrics through a web UI, and then we would sync the configuration from cloud storage to the statsd exporter instances using a sidecar. We also were early adopters of the native histograms, and we managed to actually retire all this web UI for configuring metrics and just using native histograms for all of our metrics. Before we talk about the first iteration of our solution, let's talk about the statsd protocol and statsd. Statsd was initially developed as a daemon to summarize metrics from applications. It has some design principles, like being simple. This meant a simple protocol and a simple way to instrument your applications, and also had in mind to have a small footprint because it didn't have any state on the client side and was using UDP as the protocol, so the applications could not be crashed from metrics instrumentation. The text-based protocol from statsd works like this. You have the metric name, a value, and a character representing the metric type. So for a counter, you could have a metric called metric name with a value of 3, and then a C representing the metric type of a counter. For histograms or timings, as they are called in statsd, you could have a metric called some latency, then a float value representing milliseconds, and then the metric type, which is H, in this case representing histogram, or you can also have MS representing a time. And you could also have a gauge, for example, using to measure temperature with a value of 40 and a G for gauge. So our first setup looked like this. We had the application sending metrics via UDP using the statsd protocol to a daemon set running in our clusters. This daemon set was the vendor agent from our vendor solution, and it would forward all the metrics to an envoy proxy running as a sidecar. This envoy proxy took care of load balancing all these UDP requests against a set of Prometheus statsd exporters. After a while operating the solution, we had some problems with it. Mainly, some of applications were sending metrics at such a high rate that the statsd exporters could not keep up. Also, we had high series churn in the statsd exporters because the envoy proxy was doing a great job of load balancing the requests, but it didn't have an idea about which series it was sending to every exporter. So in the worst case scenario, you could have one single series living in not every instance of the statsd exporter, causing huge cardinality and also causing high series churn. So our main takeaway from this first iteration was that we needed some tool to protect the statsd exporters from getting these high data rates, and also to ping series to specific exporter instances. This way, the exporters would only keep in memory some subset of the series that were created on that cluster. We also had problems with the statsd exporter itself. As I mentioned, the throughput was not as expected, and we also knew that we were using it outside of its use case, where it's usually deployed as a sidecar to the applications you are observing. We had some problems with counter and histogram resets due to the TTL we were using to deal with churn of metrics in the exporters, and this will be probably solved by the created timestamp being introduced in Prometheus. We also had high memory usage due to the statsd parsing algorithm, which was creating a lot of strings in memory during parsing. To solve some of those problems, we decided to fork the stats.d exporter. First, we introduced the 0 samples on the first scrape of counters and histograms, which looked like this. You had a counter at some point in time. You would include a synthetic sample on the first scrapes of the counter to make Prometheus calculate the rates correctly. We also improved the stats.d parsing algorithm to use less memory, and we introduced parallel parsing of stats.d samples using coroutines and buffer channels, among some other contributions that we managed to submit upstream and got accepted. Now that I talked more about the stats.d exporter and how we work at Shopify, I'll leave to Philip to talk about the stats.d load balancer and how it plays a crucial role in our solution. Thank you very much.
Cool. All right, so with kind of that context, now that we have that context, we wanted to briefly explain why we have this component called a load balancer for stats.d packets and why it plays such a crucial role to allow us to handle the amount of data that we have. So as Pedro mentioned briefly, the canonical way or the typical way you would run the stats.d exporter is to deploy it as a sidecar to an application that emits stats.d metrics or metrics in the stats.d format. Then each application would talk to this local sidecar and will set packets to this local sidecar. The sidecar converts that to the Prometheus exposition format, and Prometheus can then scrape the sidecar. Now, at the scale that we run, there are several problems with this approach. First is, if we imagine that we have this kind of very simple small metric called checkout duration seconds, let's just say that it has cardinality of 1, so it has no tags, no labels. When each application kind of emits this metric to the exporter, that metric is going to be created in each exporter. And with Prometheus scrapes exporters, it's going to attach what we call target labels. And now what we've done is we've gone from cardinality of 1 to cardinality of 3. So we get this kind of inflation of cardinality by attaching target labels. Now you can't just drop these target labels. They're required to do aggregations when you're kind of pulling metrics. So for us, because of this kind of property and behavior, this was creating a lot of, like, with hundreds or thousands of instances, this was creating a lot of, this was very cost ineffective to run this way. The other problem is we don't actually own all applications, so every application would then have to create a hard dependency on this sidecar that we kind of are on call for, and then we end up being on call for every application out there. It's hard to roll forward, it's hard to roll back. Things just become very, very messy. And then the next iteration of that, you can still run the exporter as a daemon set. And this is something you can typically do if you run the OTel collector, for example. It's common to run the OTel collector as a daemon and then interact, like every application on the node will interact with it. The cardinality increase that you get is not as high. Now the scrape target is actually the node, but it's still higher than the original cardinality that the application metric has. The other downside is you get very uneven resource distribution. You get a lot of hotspotting. Some nodes become very resource intensive, and you need to kind of, every node basically, or every exporter on a node becomes a snowflake. You need to manage resources manually. And you also tend to kind of reduce the size of your clusters because you have to allocate a certain amount of memory to each node and to each exporter, and each exporter runs on a node. So your cluster size kind of shrinks. And so this is where we've kind of decided to go with somewhat of a crazy hybrid approach of introducing this thing that we call the packet load balancer or stats.d load balancer, which is still a daemon set, but it's much more lightweight. It's basically a domain-specific proxy for stats.d packets. It uses DNS discovery to discover kind of downstream exporters. and it uses a method called consistent hashing to pin individual series to an exporter. This allows us to also auto-scale these exporters, so we don't have coupling between an exporter and an instance or an exporter and a node, so they are fully decoupled for the lifecycle of the application. So now when all applications or all instances, for example, emit this one metric that has one time series, that time series will end up getting pinned only on one exporter. And when Prometheus scrapes the exporter, it's still going to, we end up paying this cost of cardinality of one time series. So now that we've kind of built this pipeline, or maybe to just talk about the drawbacks. So the drawbacks here are that we don't get this up metric, for example, that you would get when you scrape a target directly. But for us, these application metrics, we consider them to be business metrics or domain-specific metrics. So we don't really care about, we never want to get a breakdown of how many checkouts we have per application instance. That's not something that adds value to us. So kind of losing this up metric or losing target labels is a perfectly acceptable solution. So to illustrate why this is so effective at our scale, this chart shows the amount of, or the ratio of nodes to exporters broken down per Kubernetes cluster. And we see that in some clusters, we have as many as 150 times more nodes than we have exporters. So we're able to handle all of this metric load with far fewer exporters, and we don't have to pay very high cost for cardinality. So now that we have this kind of pipeline in place, we were also able to add various checks in the pipeline that are that allow us to drop metrics, so we can drop them at the load balancer level. We can enforce certain label limits. For example, we can detect things like whether a shop ID was leaked or whether a customer ID was leaked in the label name. We've also had things like Ruby objects getting shoved in the label values, so we can also drop those in a much more efficient way. But the biggest benefit that we get from this kind of pipeline is that we can actually safely drop labels, which is not something that we can do with relabel configs. So if we take this very simple example again, where we have a checkout metric, it has 2 time series, gets emitted from one instance, and we have this user ID label here, which we've, let's say, determined is very, very high cardinality, as it usually is. So with a push-based, delta-based model, we can simply drop this label, and from the load balancer is going to send checkouts 3 and checkouts 1 to the exporter, and because these are deltas, the exporter is going to aggregate them. It knows that this is a counter metric, so it's going to sum them up. If we did this with Prometheus, for example, if we drop the label with the Prometheus relabel config, when Prometheus scrapes the target, it will see a time series checkouts with a value of 3. It's going to ingest that. And then the next series is going to have the same label set as the previous series. So the second series will actually get ignored. It will get dropped from the scrape as an out-of-order sample. So if we drop labels with Prometheus, we can actually lose data if we're not careful. Yeah. Now, there are definitely downsides to kind of having, pushing deltas. We see a lot of, for example, hot loops. This is not actual code, but let's say it's based on a real story. If we have a hot loop like this, where we kind of try to get something from Redis, and then if the key exists, we call this stats the increment method. This actually doesn't increment the value in memory. If you're not careful, this will actually push a packet. So your client has to be kind of sophisticated to do local aggregations first before it emits values. But then in a language like Ruby, where we cannot aggregate across requests, the more popular the service gets, the higher amount of traffic it's going to generate for metrics. And so this is why we've decided to kind of solve this problem at the load balancer again. So we would, on a very small interval, like a few seconds, we will batch packets together. We will do the local aggregation. So in this case, we know this is a counter. We know these are deltas. We'll sum them up, and then we'll forward that to the exporter. So probably we get some out of order aggregations here. It's probably not as precise as when you scrape with Prometheus, but again, for the cost-benefit ratio for us is fine. And yeah, this also kind of chart tries to show why it's kind of so effective to do this even at very short intervals. This chart shows the amount of incoming versus outgoing packets. And we see that we're able to kind of reduce the bandwidth that we use by about 95% just by having like very short-lived, a couple of second buffers. All right, and then that's kind of the overview of the solution. What we're looking to do next, and what we're currently working on, is having more proactive label dropping. So we want to have more automated detections for high cardinality, and we want to be able to drop labels before we ingest that cardinality. So this chart here on the right side shows a case where we were taking, developers were adding kind of unsanitized user input from a form into a label value. So during a flash sale, the amount of values in this label just exploded. So we ended up ingesting 200 million time series just from one metric. Obviously, this makes the metric completely unusable. You can't query it. You cannot do anything with it. So we might as well just drop it if we detect something like this. Serverless environments can also be very challenging to pull metrics from. So we think this might be something that we're looking already into the approach like this for serverless. And we're also kind of eager to see what the OTel support is going to bring to Prometheus and whether some of this can be replaced or maybe more tightly integrated. And that's it. That's all I had. Thank you very much.
All right. Any questions? Yeah, you should. We messed up. Just go for it. Any questions? Oh, yeah, OK. I'm going to go with this one for now.
You mentioned that you were mainly looking at business-type metrics where the instance doesn't matter. Do you have any need or situation where you do want to be able to locate a pod that's failing, a node that's failing, things of that nature?
Yes, definitely. But we think that we get enough information from kube state metrics, cAdvisor, so from infrastructure metrics that actually monitor pods and nodes. So what we don't want is to have target labels on each business metric, but rather have one metric maybe that has these target labels attached.
Any other question? Okay, so I have a question, if I can. So you mentioned the proactive kind of like stopping of the tsunami, and you mentioned the dropping labels and various kind of like enforcers verifications. How the source of this metric is notified that they're making problems and that their valuable information is not actually monitored for some time? Like, is it a problem? How you kind of like notify those people? How you, like, is it like you have to manually do that? Like, what's the pipeline?
Yeah, I think that's a very hard problem to solve for us because we have, I think close to 1,000 teams right now. We're trying to enforce a convention where each metric can have the service name or the team name maybe, and then based on that, we'll be able to link back the metric to the team that owns it, and then we'll be able to add some notifications there.
So just a quick question. Maybe you said that, so sorry if I missed it, but Is it an open source project, this StatsD load balancer?
No, but we're happy to kind of collaborate if there's interest and to make it open source to help kind of maintain it together. We're definitely open to that. Yeah.
Any other question? Yes.
If you know you have a question, please raise your hand earlier so we can, like, during the first question already walk.
Okay. How do you deal with restarts of the StatsD exporter?
So, yeah, when the exporter restarts, we do end up losing some samples, but that's, we think, the same as with any target restarting. Basically, it ends up being treated as a counter reset by Prometheus. And as Pedro kind of mentioned, we've kind of implemented this created timestamp that Bartek talked about yesterday by emitting a 0 sample before the first scrape. So that also gives us a way to calculate the first rate when a time series appears correctly.
And do you sometimes have the case where too many restarts at once and a subset takes too much traffic and so they all bootloop, basically?
Right now we don't, because we do have this load balancing, so resources tend to end up being well distributed. And we can auto-scale, because of the consistent hashing, we can auto-scale and we can add more resources if we detect high memory usage.
Amazing. Maybe last question, anyone?
Okay, thank you, Philippe.
Thank you.
You all can already get your phone ready. You're about to scan a QR code. I'm gonna like build up and then we'll back in like a minute or two. Yeah. Jesus, are you here? I'm looking for, no? Okay. Okay, has everybody scanned the QR code? You need to get your phones out, scan the QR code, join the thing, everybody participates. No way you're here. Gautam just wrote me he missed his alarm. I don't know how he just time traveled. Okay, but everybody, please scan the QR code. We're doing a quiz, and you can answer with your phone, and we'll have a gift for the winner. Where did it go? I think yes, have my lock screen popped up. Okay, so everybody please scan the QR code, and you can join with your phone and put your name in, and then you can answer the various questions we're about to ask. We have some trivia questions about Prometheus and the ecosystem, etc. I'm just going to wait until Gautam is here. Yeah, but we're at time, so. Has everybody joined? Can I see how many people already joined? Have no active polls at the moment? No. Then I need to do something. Click on play. Does it start? I've never used this before, so. Aha! Ooh, perfect. Yeah, don't look. Aha, there we go. Well, I need to start it. Thank you, Julius. You can kind of come up and say, are you awake yet?
I don't know.
Let me move this.
All right.
All right. 78 people.
Oh, that's
Are we
pretty
still
cool.
80? $81. Richie. I didn't even plan for this to take 5 minutes for everybody to scan the QR code, but we don't have
Richie.
so many questions, huh?
Yeah, we have Richie.
You made it, Richie. Anyone else trying to scan, to join? Okay. Well, so we unfortunately weren't able to have the next speaker that was on the schedule until a few days ago, but we, came up while setting up on Wednesday with this thing. Jesus also was involved, so we just thought we'd ask some trivia questions. And the very first one, does it work with the clicker? Nope.
All right. This one?
Yes.
Start the quiz. Okay.
Okay. So when was Prometheus created? And you have 10 seconds. 2009, 12, or 16?
There was a movie in 2012 called 2012, I think.
Ooh, nice. All right, that was too easy, but it's the first question, right? So yeah, 2012 is correct. Let's see if this works now. Yes, it works.
Okay,
you can
all right.
You can walk around and stuff. Yeah, next one. Where was Prometheus created? Munich, London, or Berlin?
London, obviously.
Yeah, I think the faster you answer, the higher your points get. Also very good. Nice.
Wait, somebody believed me when I said London?
2% fell for it. Okay, perfect. Yeah, Berlin, obviously. And the next question is kind of like going into that, at least if I remember correctly. Yeah. At which company was Prometheus created? SoundCloud, Grafana, or Google? Julius, you should know. I didn't expect that to be that high. That is impressive.
I mean,
nice.
I didn't expect Google to
Google
be
is 0. Then again, it was inspired by Borgman, which came from Google, right? So Shout out to Google anyways. But yeah, it was created at SoundCloud in 2012 in Berlin by Julius and Matt Proud. Anything else to add on the history of Prometheus there?
I mean, there's a big inspiration from Borgman and Google.
Yeah, Borgman, the Google system.
Mainly created it at SoundCloud.
Yeah, okay. So, because you wanted something like a Borgman in the open.
Had a cluster scheduler before Docker even existed, and it was impossible to monitor stuff on it with existing open source monitoring tools. And there were a bunch of other reasons.
Yeah. Okay, so nothing quite like Prometheus just repeating for the live stream. Nothing quite like Prometheus existed for something that wasn't there at the time, like a Kubernetes or something more dynamic. So that's why it exists now. You want to read the next question?
Yeah, sure. Which year did Prometheus join the CNCF?
Do you know?
I have no idea, honestly. All right. Ooh, okay.
That is finally something more interesting.
Yeah.
Correct, 2016. So yeah, 2016, if I remember correctly from my own slides with Julian yesterday, 2016, Prometheus joined CNCF, and also the version 1.0 was released, so 2016 was a big year for Prometheus.
Cool. Oh, why is the Prometheus logo orange? And you have 15 seconds now.
Yeah. You're learning something today.
Yeah, I mean, this is the first time. Why is it orange?
So what's your answer? Why is it orange, Gautam?
I think SoundCloud logo is orange.
Well, you're wrong. Yeah, just because it's like orange like a flame, but I guess, yeah, maybe SoundCloud, I don't know.
But give me a second. That
Okay,
looks red and not orange to me.
Yeah, that's the print. Okay.
Okay.
But yeah, it's orange because of like the Prometheus story, the mythology, and like the fire and everything. But yeah. Okay. Learned something new, Gautam.
All right.
How many stars does Prometheus have on GitHub?
This is easy.
For you.
We have an exporter for this.
We have an exporter for this? But you're also like always looking at it. Because there's the most important metric after all, right?
Yes.
Okay, so yeah, 50 is correct. You all got it right. Then again, Gautam, when we initially wrote this question, pointed out that 40 is also right? Like, if it has to have 40 to have 50.
Yeah.
But yeah, 50 is correct, and we just recently reached that milestone. So big, impressive milestone there. How many team members does Prometheus team have these days? 17, 23, or 28?
Unfortunately, I know the answer to this question.
Why?
Because I want to increase that to 100.
To 100?
Yeah.
From which number, though?
From 28.
Correct. So yeah, I think up until 2-3 years ago, it was like roughly 20-ish, close to 20-ish, but we've since increased. We've invited new people. Feel free to also, again, watch the talk from yesterday where we talked a bit about all of this and how it came to be.
So all the questions are from your talk?
Yeah.
Okay.
Now, potentially, we wanted to see if people paid attention.
To your talk?
To my talk, yeah.
Okay. Just checking.
Yeah, okay. Maybe I looked at your talk, maybe not. We'll find out.
We'll find out, yeah.
How many service discoveries does Prometheus have? So like the Kubernetes, the file system, the service discovery, all of these. There are a bunch. So probably more like 2. (27) Still an impressive number, right? Like considering that like Prometheus is able to discover targets to scrape on like 27 different systems and be able to pull from all of them. And I think that also has slightly increased since the moratorium was lifted again.
Yes.
Because we had for, was it 2-3 years? We didn't add any service discoveries, I think. So yeah, it's been growing again. Like Hetzner is a fairly recent one.
By the way, if you want to add a new service discovery, just send a PR and convince one of the 28 members that it's a good idea, which is very, very easy. Just give them beers and you'll have your service discovery in Prometheus.
Yep. Okay. Prometheus was created with Kubernetes in mind. Yes, no, or maybe?
This is easy. Come on, folks.
For you. Okay, impressive, and most of you are correct. So Prometheus was created before Kubernetes existed, I guess, and that's why it didn't even was possible to just create it for Kubernetes in mind. But kind of like coming from the dynamic world of those workloads, it plays along nicely, and I guess that's also one of the biggest reasons why so quickly after Kubernetes, Prometheus joined the CNCF, right? They kind of are a match made in heaven.
Yeah.
So, yeah. Finally, something interesting. Did you pay attention in computer science class? So which parts of the CAP theorem does Alert Manager clustering cover? CA, AP, or CP?
Or all three.
All three? Good one.
Let's see. Oof. It's pretty good.
It's pretty good. So yeah, the AP is correct. So it isn't consistent most of the time. It's trying to be available and partition tolerant. So we can always, worst case, send duplicate alerts and stuff, right? I think that's the biggest reason. We'd rather be a bit more inconsistent, but still alert in just in case anything happens and you get 2 alerts instead of 1, which might not be so bad compared to not knowing your system's down.
Yeah.
Cool. What do single quotes do in PromQL? And you have 30 seconds.
I cannot parse the first statement.
They work like double quotes, but without expanding escape sequences. So you don't need to put a backslash in front of them or something, I think.
I see.
I didn't write the answer, don't ask me.
I think they're invalid.
It's good to have you on stage to prove that you know nothing. Okay, so yeah, apparently they just work like double quotes. You can use them as well. I think if you then press the format button, like when you write queries in the Prometheus UI itself, you can click on this like format button for, I don't know, like a year or so. It's there. It might replace them with double quotes. I didn't check before, but apparently you can just like use single quotes as well, and then your queries are just fine. Usually, all of the queries are. Julius is verifying on your phone. Yeah, I'm not so happy with the mobile-friendly user experience of the Prometheus UI. I've tried to do that a bunch of times, but writing queries on the phone is quite. But yeah, let us know if you can manage to find out right now. But you also need to answer the questions, right? Should we wait for you? No. Okay. Yep. So that's something I wasn't really aware of either. What does the add modifier do in PromQL? It immediately sends an alert to the route named after the add, or it changes the evaluation time for a vector preceding the add, or the add doesn't even exist in PromQL.
It does exist on X, but but I don't think that's the question. Okay. Now I'm starting to feel a little better. I know the answer to this question.
Okay, go ahead.
Yeah. Nice.
So only 2% said something incorrect, and 58% 98% said the correct thing, which is that it changes the evaluation time for the vector preceding the add. So you can like pinpoint a query to a very specific time, or actually the vector within a query, right? So that is something, I think, what was it, like 2.30 or something added this like a while back, but yeah.
So 40% of you are correct 1 year ago, not anymore.
Or like, yeah, exactly. But you need to read the change logs. How many versions of the Prometheus storage were implemented? So that's an interesting one. So like the underlying storage versions. There are 2 major versions of Prometheus, right? And that's kind of the trick question. Good one, Bartek. You came up with it, I think. So yeah, there are 2 versions of Prometheus, 2 major versions. However, there are 3 storage versions. And I believe that there was a first version in the first major version of Prometheus. Then there was a second version in the second major version of Prometheus. But that version was, I think, within like a week already replaced because it had some flaws. And that's why basically since Prometheus version 2 was released, everybody uses the version 3 of the storage. That's how I remember it. Is that correct?
I included the early ones.
Yeah.
The early ones? Okay, fair. We're talking about like V1 and after, Julius. Okay, but yeah, impressive. I guess it was a tricky question, and that was the point of it. So another tricky question. Which format does Prometheus have never ingested when scraping? JSON, protobuf, or CSV files? So it's a negated question, right? Has never ingested. You're thinking hard.
Yeah, I know.
CSV. Okay, and that is actually correct. So JSON is kind of a really funny, and that's kind of like the trick here. And that's probably pre-1, but Frederick had this like random fact yesterday at the social event. He was like, "Did you know that Prometheus at some point was able to scrape JSON?" Sure, I didn't, but here we are. JSON at some point was being able to scrape and ingest, but I don't think it has been for a very long time. And usually it's the text exposition format and protobuf these days for histograms.
Should we bring it back into fashion?
Sorry?
Should we bring JSON back into Prometheus?
I'd rather see CSV files.
Okay.
I don't know what that would look like, but yeah. No, I'd rather not. I would rather see protobuf, but
Yeah,
we
it's
like
coming
how readable it is when you hit /metrics, right? So XML? Yeah, that was the other option before, but it was too obvious that it was like the wrong answer. So we went with CSV.
Proxy exporter grabs CSV from HA proxy at least.
Okay, the exporter, HA, but then converts it to the exposition format, right? Okay, okay, interesting. HA proxy exposes CSV. Cool. How many projects depend on client Golang? So that's the client Golang library. So 10,000, 20,000, or 40,000. Yeah, that's where everybody needs to rely on their gut feeling.
Yeah.
I had no idea.
I mean, I think it's a lot of projects.
But 10K is a lot of projects already, right?
I know.
But is it the right one?
Oof.
It's 40,000 projects. Like, you can go on, what is it, like package.go.dev, and you can open the client Golang there, and you can see that like 40,000 projects are depending, like importing Prometheus /client Golang.
So we just need to push a breaking change.
Yes, we break everything. We can break the world. Yeah, but
or we should mine crypto.
No, but yeah, like it's such a widely used package. It's insane to see how far it has come, and everybody at some point has a dependency on it to expose Prometheus metrics. What does the dot operator in PromQL do? Either it separates a namespace for the metric name, it selects a field in a native histogram, or it doesn't even exist.
This is a trick question.
Wow, not bad. And you're right, it doesn't exist in PromQL.
In a few months, though.
That's one we can like copy for like next year,
Yeah.
and then like all of a sudden it's actually a valid operator in PromQL.
Wait, somebody thinks it separates namespace from metric name. They didn't listen to my talk.
There's your talk reference there. Yeah. So yeah, like if you want to use a dot, it doesn't do anything. I don't know if the parser even like throws an error or something. Probably does.
It does, yeah.
How is the metric name stored in the time series database? So like the metric name before you put the labels in, where do we store it? How is it stored? So that's more of an intricate question. I don't know. To be fair, it wasn't like the best question I came up with.
Okay.
But yeah, it's just a label name. So what we do in Prometheus, we like the metric name is in front of like the curly brackets, right? And it actually is just a shim in a way. The metric name is also put into the curly brackets behind the door, or yeah. It's the label value, not the label name.
Yeah.
That is right. So yeah, it isn't the best question. I'm sorry about that. But it's like stored with like all the other labels and then identified as the metric in the time series database. So it isn't like stored in a B tree or an LSM or anything. I mean, doesn't even really is able to be stored in an LSM. Like that's one of the answers that I wasn't so sure with, but needed to come up with something, right? But yeah, it's just another label value. So which of these CLI arguments don't exist on the current Prometheus version? And I'm not going to read them.
Who came up with this question?
We can check the spreadsheet. Maybe
This is a good question.
Timestamp tolerance. So everybody needs to read the docs because timestamp tolerance does exist and we can figure out what it does, but there's no local target heap size of some sort, probably to limit the memory or something.
We're not Java, we're Go.
But yeah, I guess everybody at some point had to turn on debug logging, so most of you know that this one definitely exists. Which answer is a valid metric name?
Wait, two of them are the same.
That's a copy-paste mistake, I'm sorry. Yeah. I don't know. I'm sorry. I copied these in the taxi coming here. I had one job. I can fail organizing PromCon, but this slide. So yeah, I guess. I guess that's the real trick question after all. Unplanned. But yeah, metric names can't start with a 0. And I think the other one was with an underscore at the beginning, if I remember correctly. How long can Prometheus retention be?
This is an easy question.
Nice. Yeah, 15 days is the default. I looked it up in the previous talk. But yeah, 33 days is usually what people, or 31 days is usually what people do if they want to have a month of retention, but then have some extra space or time at the end. So they definitely have like a full month of metrics available. But yeah, you can use like more than a year. You can even do 2 years if your disks allow? I don't know.
You can't do more than 11 years because Prometheus didn't exist back then.
Yeah, okay. But you can, like, in the future, do 11 years. That is right.
That is
but
true.
The other, like, it's the same with, like, the 4,000 stars, but we also have 10,000, right? Yeah. Which PromQL query is correct? If I mess this up again, it will be fine. Nice.
Okay, nice.
Very good, very, very good. And yeah, the last one doesn't have the window, the rate window, right? So
The first one is also correct if you like wrong answers.
yes. Like the parser won't complain, but you can have an arrow to the knee, right?
Yeah.
Again, PromQL query, which is correct? Oh, just now I realized we can see how many people answered on top.
Yeah.
So, Gautam, what do you say?
The first one. Yeah.
The first one? That was the actual trick question. All of them, because we have native histograms, people. So yeah, like the first one is what everybody used to do. But yeah, since a year we have native histograms. So histogram fraction, histogram count, and histogram sum are just valid functions as well now, and you can use them with the native histograms. So the old one, like the one we know, the histogram quantile, like that also works with a native histogram. And if you pay attention, the first one doesn't have the trailing underscore bucket. So that already is also using a native histogram.
Pretty cool.
Yeah. So I guess that is almost it. I didn't manage to put this to the front because then we had to go on stage. Sorry?
Is it the first PromCon or the 0th PromCon?
Yes. The 0th. Julius, you should know. So yeah, it was the 0th one. Okay, I guess, yeah, 0 first. We need to find a proper definition.
Do we have winners here?
Yes, so 23 questions. We have Raul, who got everything, I don't know, not everything right, but you were the fastest usually to answer. And this Julius, I don't think we should give him a mug. That's like... And then who is confused, but like, yeah, you, the three of you, you can come to the registration desk and you'll get one of the speaker gifts as well, because you did so well here.
Cool.
The hardest question, which PromQL query is correct? Interesting. So it was the last trick question, I suppose. So yeah, people, learn about native histograms. That's the summary of the quiz.
And timestamp tolerance, whatever that is. I have
Whatever
no idea.
that is.
Yeah.
But native histograms. All right, we'll be back for the next talk. I don't know. Yeah, I think in 2 minutes. All right, thanks. Okay, so this was fun. Thank you all for participating. Worked way better than I expected. But now back to actual talks and more content. I'm very pleased to have Fabian on stage. He's been working on Prometheus Java client, and you've been in Prometheus team 2 years almost?
Something like that, yeah.
Yeah, it's been a while.
Yeah.
So really, really cool to see the fruits of your labor of the last year or two. Stage is yours.
Cool. Yeah, thank you. So that was fun with the quiz. So really cool. We should do that every PromCon, I think. This one is not so much about fun and entertainment, but hopefully about cool features and cool things happening in the Prometheus ecosystem. The day before yesterday, the Prometheus Java client library 1.0 came out. And yeah, I'm going to walk you through it, present you the latest features and what happened and so forth. Few words about me. So I'm Fabian. I work at Grafana. I'm a member of the Prometheus team. And as you heard in the introduction, so I'm maintainer or one of the maintainers of the Prometheus Java client. So if you have anything in the release that you like or don't like or any wishes for the future, so talk to me. I'm always happy for feedback. So the 1.0 release is not a regular release where you just update the dependency and then you're done. It's basically a complete rewrite of the underlying data model and the way that the library works and so forth. And for that reason, a lot of things changed, and there are a lot of improvements and things that are slightly different and so forth. So it's like hard to come up with a complete feature list or a complete list of things that are new. But if I had to pick like two highlights or two like important things that come with the 1.0 release now, I would say it's native histograms and its support for OpenTelemetry. And I'm going to show you that. And as it is more or less a complete rewrite, it's also not backwards compatible. But if you are a user of the previous version, 0.16 or older, you don't need to refactor all your code now because we provide a migration module. So you can use that and bridge your previous metrics from the collector registry with the new Prometheus registry, and then you can kind of keep using your old metrics. So no need to adopt all of your code at once, right? Cool, so let's get started talking about these features. Let's start with the histogram. So this is how Java looks like, in case you are coming from a different programming language. So this creates a histogram, pretty straightforward, with a name, help message, unit, a couple of labels. And it's an example of how you would use the histogram to observe a duration. Of course, there's more API. You have different ways to observe durations and so forth, but this would be the most simple case. And as I said in the introduction, that native histograms are kind of one of the new features here. I think the first question is, if you look at this code, it doesn't specify anything, right? It just says, I want a histogram. And so the question is, if you do that, what type of histogram do you get, right? And the answer to that is, by default, this one will maintain both representations under the hood. So under the hood, it will maintain a classic histogram and at the same time a native histogram. And which one you actually see depends on how you configure your Prometheus server. So if you have a standard Prometheus server today, then the Prometheus server would scrape in open metrics format and see the classic histogram. And if you start your Prometheus server with the native histogram feature flag enabled, then it would scrape the new protobuf format and receive the native histogram. And there's also a configuration option in the Prometheus server to scrape both, which is intended for migrating from the classic histograms to the new histograms. Okay? If you want to try this out, there's something like it's more like a tiny thing, but I think it's pretty helpful. So what we did is we added an examples directory here in our GitHub repository. And the examples directory contains end-to-end examples of all the new features and a couple of older features. And the intention is to extend this over time. And what these have is basically example Java code so that you can set things up. but also a Docker Compose that sets up a whole pipeline, with a Prometheus server, Grafana, dashboards, and so forth. So for example, if you go to the example native histogram here, you have a tiny Java program that produces histograms, but also a Prometheus server that's configured to scrape both representations, and then dashboards that show you how the different representations look like, and so forth. And so basically the idea is to keep maintaining these things so that for each feature you have some working example to try out and learn about it and explore things, and then you can go from there. So back to this code. There's one thing I want to mention. So this one doesn't configure anything, like really it's just the defaults, but of course you have API here to really fine-tune what type of histogram you want. You can say, I want a classic histogram only, and with these custom histogram buckets and so forth. However, there is an issue with that, or there was an issue with that with the previous releases of the Java client, which is that typically at the time when you write that code, you don't really know what's the best configuration for your histogram. Like especially with classic histograms, when you specify your buckets, it often happens that you kind of don't really know what buckets to use. Maybe you guess something or just go with the defaults. And then when you deploy your application in production, you kind of see that the actual latency numbers that you observe are not a great fit for your histogram buckets or whatever, and then you would need to get back and reconfigure. And with previous versions of the library, the only way to do that was, get back to coding, put a different configuration there and create a new release of your application, which is obviously annoying. And so with the 1.0 release, we made almost everything that you can configure in code also configurable at runtime. So we have here's documentation for that. So there are different ways how to do that. You can specify a properties file, or you can specify, like if you just want to set one or two properties, you can also do that via a command line, via system properties, and so forth. And like these are the examples for metrics. Like if you, for example, you can say, I want the classic histogram only, and I want to use these upper bounds, and so forth, right? There's a lot of things you can configure. And this is not only for metrics, it's really for everything in the library, right? So these are the metrics properties. If you scroll down, there are for exemplars, for whatever. If you have the built-in HTTP server, you can specify which port it should use and all these things, right? So basically, you can override almost all of configuration at runtime, which is pretty helpful. And by the way, what we're looking at here is also something new. This is the new documentation that's hosted on the GitHub pages here. So the link to that is in the README file. And yeah, so it's kind of pretty extensive. So we have, quick start, walk through all the metric types. Callback metrics is something new that we introduced. If you want to define a metric, but call a callback to get the current value, hints how to use the API in high-performance applications, and so forth. We are going to extend this over time, and so try to not only provide a good metrics library, but also provide good documentation, which was kind of missing in the previous versions. Okay? Cool. So that was a little bit about histograms and about documentation and how to configure things and so forth. So let's move on to the other highlight feature that we have. With the new library version, you can now push metrics in OpenTelemetry format to an OpenTelemetry endpoint, right? Typically, the OpenTelemetry endpoint would be an OpenTelemetry collector. So if you are new to OpenTelemetry, this is OpenTelemetry collector is a project by the OpenTelemetry community. It's an open source project, and that's typically used to receive OpenTelemetry data and do something with that. For example, write it to a Prometheus server, which wouldn't really make sense in that case, but anyway. If you're interested in an example, of course, the examples directory has an end-to-end example of that as well, so basically setting up the whole thing. If you look at how that works in code in the example, it's basically just taking the defaults. So I initialize this OpenTelemetry exporter. The only thing I set in the example is I reduce the push interval to 5 seconds. So usually, the default is 60 seconds, which is good for production. So every 60 seconds, you push metrics for a demo, you don't want to wait 1 minute, so I just reduced it to 5 seconds. But obviously, like this is just going with the default, so it will push to the default OpenTelemetry port on localhost. Obviously, you can configure a whole lot of things here in this builder pattern, and of course, you can override all the configuration at runtime as well. So if we get back to our documentation here, you see a couple of examples, which protocol to use, which endpoint to push to, custom HTTP headers, so in case you want to do HTTP authentication, and so forth, right? So lots of configuration options that are supported. So this is already cool, and also it kind of gives you the option to push metrics in OpenTelemetry format. However, if we aim at good integration with OpenTelemetry, this is not the whole story, right? Because OpenTelemetry is more than just a definition of a transport protocol, right? And one thing that's more in OpenTelemetry is that OpenTelemetry defines not only the protocol and the protobuf and how to push metrics. OpenTelemetry also defines standard metric names and label names. This is called semantic conventions in OpenTelemetry. And so, for example, OpenTelemetry says, if you monitor an HTTP service, then you must always have a histogram named HTTP server requests, right? And the idea is basically that if everyone uses these standard names, you can have standard dashboards based on these names and so forth. There is an issue with that, though, which is that those standard names in OpenTelemetry usually have dots, like HTTP .server .requests, and dots are, currently at least, an illegal character in Prometheus metric names. And what we did now in the Java library is we allow dots in metric names. However, you will never see the dots, because if you expose the metrics in Prometheus format, they will be automatically replaced by underscores under the hood. So if you just use your library, even if you create a metric with dots, you will just see the underscores in Prometheus format. But if you push your metrics in OpenTelemetry format, then you will see the original names with the dots. And the reason why we do that is because if you instrument an application now, you might choose to use standard metric names and label names coming from the OpenTelemetry standard. Maybe you don't need to now because you don't use any OpenTelemetry specific tools, but this prepares you for the future if at some point, whatever you decide to use standard dashboards all based on OpenTelemetry names, then it's probably a good thing if you're using standard names in your instrumentation already, because then you don't need to change anything, right? And just allowing dots under the hood allows you to do that today, even if you don't use that, so that you're prepared for the future. So that's the naming part, and there's even more things that come with integration with OpenTelemetry. So the next thing is how it works together with tracing. So basically, OpenTelemetry, as you might know, is not only about metrics, it's actually mainly about tracing. So tracing is the strongest part of OpenTelemetry and the oldest and most mature, but it has metrics as well, logs, and they're working on other signals and so forth. And the way OpenTelemetry works, it's on purpose designed as a loosely coupled standard, with different components. And so it allows users to pick and choose the parts of OpenTelemetry that they like without forcing them to use the other parts. And so what that means in practice is you can, for example, decide to use the Prometheus Java client for instrumenting your application with metrics, but at the same time use the OpenTelemetry Java agent and attach it to get distributed traces. And for that scenario, the Prometheus Java client has a couple of magic things that then happen under the hood that make this scenario really a smooth experience. You don't really need to know these things, they just happen automatically, but it's kind of good to know what's happening under the hood. The first has to do with these attributes named service name and service instance ID. So this is something specific to OpenTelemetry. In OpenTelemetry, an instance of a service is identified by these two attributes, service name and service instance ID. That's similar to what you have in Prometheus with the job and instance labels, right? And what happens as soon as you attach an OpenTelemetry agent to your application for tracing, for example, then the Prometheus Java library will recognize that and will use the same service name and the same service instance ID that the OpenTelemetry agent uses. And then as an effect, if you push your metrics to an OpenTelemetry endpoint and you push your traces to an OpenTelemetry endpoint, the monitoring backend will see that these have the same service name and service instance ID, and then the monitoring backend will understand that the metrics and the traces are actually coming from the same instance. So that's a nice feature. Next up is exemplars. So exemplars is nothing really new, but it's probably a feature that not many people use. So it's kind of a way to annotate metrics with links to example traces. I can show you a quick example. So I started one of the demos before this talk. So in case you've never seen exemplars, they look something like this. So this is just a latency graph showing 95th percentile of some latency. And the exemplars are those little green dots here, right? So each of these little green dots is actually a link to an example trace that happened here. And you see that there's a wide variety, so there's a couple of particularly fast ones that are well below all the other ones. There's a couple of particularly slow ones. And if you're interested, for example, so why is this one here so slow? Why is it well above the 95th percentile? You can click on Query with Tempo or whatever your favorite trace database is and start exploring what happened here. So that's basically a feature of the Prometheus data model and of the OpenTelemetry data model, that you can add these links to example traces to your metrics. And the Prometheus Java library does this automatically. So as soon as you update metrics while a trace context is going on, then it will add exemplars automatically. And this is actually nothing new. The previous versions did that as well. But there was an issue with the previous versions that is now fixed, which is that people who use tracing often tend to use some sampling to throw away most of their traces, because trace data is very repetitive. You get the same kind of traces over and over again, and it's pretty common to configure the OpenTelemetry collector and say, I want to throw away 90% of the traces and just keep 10%, because then I will still find enough examples of everything that's going on. That was an issue with exemplars, because that meant that 90% of the exemplars just linked to non-existing traces, right? You had a lot of 404 file not found. And this is now fixed, or at least there's a feature that helps you fixing it, because now with the new version, if the library uses a span as an exemplar, it adds a specific span attribute to that span, and then you can configure the sampling policy in your OpenTelemetry collector to keep all traces that are marked as exemplars, right? And that way, you will never have the dead links in your exemplars again. And also, there's a rate limit. You can configure, I want a new exemplars at most every 30 seconds or something, so that this will not overwhelm you with a huge number of traces in your backend. Cool. So that's the tight OpenTelemetry integration, so prepared for that world as well. To wrap this up, I want to mention a few things that are kind of unique to the library, or that is more like the focus of the Prometheus Java client here, which is that it's still, Prometheus first library, and mostly it's focused on being a high-performance library, and that shows in a couple of different places, and even shows on the API. And this is not really new. This has been around for a longer time, but it's kind of one of the things that show that it's actually 10 years of experience went into how this API is designed. And I have a pretty simple example here, but I like it because of its simplicity. So what you see here is how you would increment a counter, right? So you have a counter, say I have labels, values, whatever, some path and some status code, and I increment it. And the tiny trick here is that looking up the label values and incrementing the actual counter are two independent operations. So if you have a really high-performance web service that try to squeeze the last bit of performance out of your service, what you can do, you can separate those two calls, right? You can look up the label values only once, and then store the resulting data pointer here somewhere. And then in the hot path of your web service, where you want to update the metrics as quickly as possible, you basically just use that directly to increment the counter. And this actually gives you more than 100% performance increase in the number of operations that you can do. And it's like there's some more of these like simple little things that just make it well suited for high performance applications. And the last thing is, you don't really need to know this because it just happens under the hood, but it's a cool feature. All of the metric types, including the new native histograms, support concurrent updates under the hood, right? So if you have a multi-threaded application, all the threads can update the data structure at the same time. And this is important because if you have a high, like I don't care about a single threaded scenario, right? If you write an application and decide to use only one single processor core of your server, then you're probably not writing a high-performance application anyway. But if you put in the effort to have a multi-threaded web service that's designed to utilize all available processor cores to the maximum to get maximum throughput, then the last thing that you want is you introduce your metrics library to measure latencies, and then the metrics library introduces synchronized blocks, and all of a sudden threads start waiting on each other, right? And this won't happen with the Prometheus Java client, so all of the implementations of the metric types support concurrent updates and scrapes. And there is actually a benchmark folder showing the results of that. So you see this benchmarks folder here. A couple of benchmarks in there already. Most of them focus on this updating metrics in multi-threaded scenarios. And the benchmarks looks actually pretty good. So that's nice. Cool. So that concludes my talk. So that were a couple of the highlight features here. Maybe quick outlook for the future. So when we cut the 1.0 release, we didn't port everything from the previous releases over yet. And there are actually a few things that have quite a lot of users that we also didn't port over yet, like the push gateway or the servlet filter and so forth. And of course, the next couple of weeks, we will continue porting things over from the 0.16 version to the 1.0 version so that you kind of have the complete feature set again. And of course, there's the other Java-related project in the Prometheus community, which is the JMX exporter. And we will port that to the 1.0 version as well, which will have the interesting side effect that you can push OpenTelemetry metrics from the JMX exporter if you like to do that. Cool. So that was my walkthrough, the new Prometheus Java client. Try it out, create issues, contribute if you can. And yeah, thanks for listening. Happy to take questions.
So if I'm starting my new Java application now, what guidance would you give me to choose whether to instrument it for OTel, like with the OTel client library or Java client?
Sorry,
So now we're in a position now with the Prometheus client Java supporting OTel, the OTel client supporting Prometheus. I kind of have a choice, right?
Okay.
How would you choose which one to use, or what guidance would you give me?
That is a good question. So the question is, like, there are multiple libraries. There is an OpenTelemetry library that supports Prometheus. There's a Prometheus library that supports OpenTelemetry. Which one to choose? And actually, that's like a very common thing in the Java ecosystem. There's even more. There's Micrometer from the Spring project. There's lots of different libraries. And the question is, how would you choose? So there are differences. I mean, first of all, even though we have OpenTelemetry support, that we built this OpenTelemetry support mainly with this use case in mind. If you instrument your application now, maybe you're using Prometheus scrapes today, but maybe there is a chance that in the future your company says, we're going to standardize on OpenTelemetry and push everything in OpenTelemetry format. And with this OpenTelemetry support, we want to make sure that if that happens, you don't need to throw your instrumentation away. You can just keep using it, then you just switch on the OpenTelemetry exporter and you are done. But that doesn't mean that we are going to become like an OpenTelemetry library, right? It's still a Prometheus library. It's still a direct implementation of the Prometheus data types, right? And it still does not implement some things that exist in OpenTelemetry but do not exist in Prometheus and so forth. So it's really focused around the Prometheus data model, and it's focused around being like a very high-performant and simple library. The other, like for example, OpenTelemetry is a bit more generic, is a bit more designed to work with the Java agent, is of course, a bit more complete in terms of what the kind of concepts coming from OpenTelemetry it supports. But yeah, probably a bit, you need more lines of code to use it, let's say, put it like that, right? Yeah.
Any other question? In the meantime, I have a question, if I can, again, sorry. So thanks for your talk. And my question is, do you need contributions? What's planned for the future? If anyone wants to help you with the client Java, contribute, like what's exciting you have for them?
That is a great question. Yeah, contributions are definitely welcome. I mean, first, of course, we need to port over the existing simple client modules to the new 1.0 version. So if you are a user of one of these and you want to speed this up, maybe just port yours and make a PR. I mean, that would help, right? Yeah, then, I mean, all kinds of things, right? I mean, we have these examples that we want to extend. You can also, if you're not a coder, contribute to the documentation. So, of course, the thing that we saw here, our documentation page, is also just in the docs directory on GitHub. So it's just markdown files. You can easily, write something, or implement new features, like, for example, something for instrumenting Java Flight Recorder might be nice, stuff like that. So there are a lot of ideas, instrumentation modules that don't exist yet.
Thank you.
You know who to reach out to. So.
Yeah.
Okay. Then thank you, Fabian, again.
Dankeschön.
There's your speaker gift. We are going to have the break now. Yeah, there will be snacks outside in the other room again. We are back in half an hour, 11:15. Let me check before. No, it should be exactly that. 11:15 for the next talk. We have maybe 1 or 2 more slots for lightning talks, but it's filling up quickly. Yeah, see you then. 3 more people. Okay. There are, a few more people coming in. It's very nice outside, I get it. But we have more talks, and they will be equally interesting. So with that, we are going to hear something about metrics and profiles and backend stuff. And I'm looking forward to it, because I haven't seen the demo or anything about it either. Take it away.
Thank you. All right. So first of all, if this is a surprise that I'm giving this talk, that's because someone last minute dropped out, and I was lucky enough to be allowed to step in. So not the most rehearsed talk in the world, so forgive me if there are some hiccups. But I want to talk today about from metrics to profiling and back. And if that means absolutely nothing to you, that's totally OK. Hopefully, we'll pick up everyone from zero, and we'll get there by the end. So before I get into anything, basically I want to start with a problem. And we've probably seen CPU graphs or really any other kind of graph that looks something like this, where we have some sort of spike. And we're just asking ourselves, right, like this baseline is typically around 1 CPU core. Why the heck is it now like spiking so much, right? And probably, there'll be some theories in the team. Someone will be like, oh, this is probably garbage collection, right? Like someone's going to say, this is this pathological query that this one user in our organization always does. But theories are just theories, and what's better than theories? It's data. And profiling is a tool that has basically existed ever since software engineering has existed, because we always needed to understand down to the line number where are our resources spent. And most of the time, we're going to be talking about CPU profiling, but theoretically, profiling can be done with any kinds of resources that are spent by our processes. Thank you very much. So in this particular case, what I would want to see is a CPU profile from exactly that spike. And in this particular case, I was the pathological user that was doing some very, very expensive query just so that I could produce this data. And now I could actually dive into the data and figure out that, yes, this was a query. Again, if this means nothing to you, that's totally cool. I just wanted to show you kind of the problem statement. So who am I? I'm Frederick. I founded a company called Polar Signals. If that sounds familiar, maybe that's because we organized this year's PromCon. But you maybe also know me as a maintainer of the Prometheus project. More specifically, I maintain the Kubernetes integration in Prometheus. Through all of that work, I eventually also became a tech lead in the Kubernetes project for a couple of years. I passed that on to the next generation. I'm a Thanos maintainer. I created the Prometheus operator, which I think we've heard a couple of times already. I created a project called Prometheus, which I think also a lot of you are running. And finally, I created this profiling project called Parka. So let's talk about profiling. Here is where we're going to start from zero. So how do sampling profilers actually work? So typically, sampling profilers are the profilers that we run in production because they have low enough overhead that we can actually do it in production without affecting our users' user experience. And the way that these kinds of profilers work is that basically all they do is a certain number of times per second, we look at what is the current function call stack. And we just record that, let's say 100 times per second, right? That means that if we see a stack, that means roughly statistically speaking, we've spent 10 milliseconds in that stack. Obviously, like I said, that's only statistics. But the more often we observe the same stack, the more likely that statistics actually is likely to be true and wasn't just by chance that we saw this stack once. And so the longer we do profiling, the better our statistical significance gets. And in the olden world, let's say, we looked at a process for a 10-second period of time, let's say. We recorded the stack traces, and that told us for exactly those 10 seconds that we were observing our process for, where CPU time was being spent. And there's this new kind of phenomenon happening, and you may have heard of a couple of open source projects in this space that do continuous profiling. So as the name maybe already implies, we're not just looking at a process for a 10-second period of time. We're actually always looking at the process and kind of collecting this data over time. And I always like to say this is kind of the same evolution as we've gone from like Nagios checks or something to time series and doing alerting on time series rather than just checking is this thing up, right? Profiling used to be we just do this check once, and continuous profiling is now that we're kind of systematically doing this over time so that just like with any other observability data, we're always going to want the data we don't have, and with continuous profiling, kind of naturally, we'll have the data. And so basically, like I said, with continuous profiling, all we do is really collecting all of this data over time. And there are lots of challenges with doing this, and I'm not here today to talk about any of that. There are lots of talks on the internet if you're curious about that. I'm here to talk about how does profiling actually connect with the world of metrics. That's why we're here, right? To talk about metrics and Prometheus. And long story short, it's through metadata. And specifically in the Parka project, this is something that we did very, very intentionally, and I'm going to show a quick demo about this. The whole idea is we can always find the right profiling data by just having consistent metadata attached to our profiling data as we do with metrics. And so this is going to look very familiar to people, to everyone here, hopefully, who uses Prometheus, because in Parka, we kind of have the exact same, let me make this a bit bigger, the exact same kind of labeling system, and that's not by chance, that's literally the same code as Prometheus. And so you can then say something like, your Kubernetes component label is, okay, cool, like Prometheus, for example, right? And now we can see all of the CPU data in this Kubernetes cluster related to the Prometheus instances that we have here. So that way is actually pretty easy, but that's only because we've actually designed the system to be very easy to interact from metrics to profiling data. And the Prometheus project actually has a very long history with profiling because, as you all know, Prometheus is pretty optimized for the workloads that it's meant for. And so when the Prometheus 2.0 storage was heavily being worked on, we created this thing called PromBench, which was, or still is, a tool that we can call, just like you're seeing Brian do here on this pull request, where we can just call a command on a pull request and say, OK, run benchmarking for this particular pull request and compare it against the main branch in this case. And what it then does is it kind of spins up a synthetic load and kind of starts monitoring both of those Prometheus instances and gathers all sorts of observability data. We have a bunch of dashboards where we can then see, do we have any sorts of regressions? Is the memory usage better or is it worse? Typically, we definitely always run this when we are about to do a Prometheus release to ensure that there are no regressions, so that we compare the latest version that we've released with the one that we intend to release. And that's kind of for quality assurance, but what we often also use it for is to kind of prove or disprove theories, right? We say, OK, in this particular example, actually, on this pull request, someone had the idea, I think doing these changes is going to improve Prometheus memory usage by doing some specific strategy. And having reproducible tooling like this is super useful because it actually allows us to run these experiments very easily and prove or disprove theories very easily. Now, maybe you already see where this is going, but these metrics are really nice to like see on a high level why this is happening, but when we're comparing releases, for example, where there are probably hundreds of commits in between, how can we kind of figure out what is actually the difference here, right? Like if there's a memory regression or a CPU regression, where is actually that change? Where has that change happened? And I didn't actually do these changes, but Bartek of the Prometheus team recently added Parka to the PromBench setup, and this is already kind of proven to be useful, because now we can actually not just see these high-level metrics for the comparison, but we can actually dive deep down into the code to see exactly down to the line number where are these changes manifesting, right? And that can be good, positive, or neutral. And as I was actually preparing this talk, I was kind of talking about all of these theories, and I see Jesus laughing over here because he was saying that when Bartek, he was very excited about Bartek implementing this, because this used to be a very, very kind of manual task in the Prometheus project, and sometimes we spend days or weeks finding where these problems lie, specifically because of all the problems that I've already mentioned with kind of the traditional manual profiling world, where we need to observe the process in exactly the right time, at exactly the right moment to kind of catch when there's like a CPU spike, for example, right? And that's really, really difficult to get right, and that's why we need continuous profiling for the Prometheus project as well, so that we can continue to deliver the consistent performance that we do. Okay, so now we've kind of covered all of the world where we go from metrics to profiling data. How do we now go the other way, right? So how do we kind of extract metrics from profiling data? And this is not coming out of kind of nowhere. This is actually a request we've had several times from our customers, because they wanted to kind of monitor very specific aspects of their software. So they build some sort of, let's say, some database, right? And they have a specific process that must always be utilizing X amount of resources by the process. And if not, then we need to have a look and figure out why this is happening. So they basically wanted to do alerting on profiling data. And before we dive into kind of the depths of the data that we can produce, foreshadowing, this is possible now. But before we kind of dive into that, we need to cover a little bit of terminology in profiling. So we've seen the icicle graph earlier, and essentially what that is, the x-axis is the amount of CPU time that was spent by a function, and the deeper, kind of going from the top to bottom, the deeper the stack is, the closer we get to the leaf. So, no further functions being called. In this particular case, the main function is kind of the root, and it calls iterate. And once iterate finishes, it calls iterate long. And the reason why I'm going through all of this exercise is, in profiling terms, the main function uses a cumulative CPU, let's say these are seconds, right? A cumulative sum of 11 seconds, because its children, iterate, take 1 second, and iterate long takes 10 seconds, right? But main itself is not actually doing any work, right? So its flat value, that's what this is called in profiling, is 0. It itself is not doing any work, but in cumulative, it and its children is doing 11 seconds worth of work. And then we kind of, as we go deeper down the stack, iterate only uses cumulative 1, because it itself uses 1. And then the same with iterate long, but it's doing more work. So now that we have this, we can actually produce some metrics out of this. And we created this thing that we call profile exporter, very imaginative in terms of our naming here. But basically, the way this works is it has a configuration that we'll go over in a second, where you can configure it to query Parka in with particular queries, and then it generates these 3 metrics. So it generates the one metric that gives you the cumulative of the root. So basically, how much did this entire process use if we're looking at CPU profiling data, for example. And then of each query that we're issuing, it will generate a cumulative metric and a flat metric, so that we can specifically figure out, with the cumulative value, we'll be able to say something like, this entire subsystem is using X amount of CPU resources of the entire process. And we can do that by using the other metrics for comparison. So before we get into that demo, this is what the configuration looks like. And I elided a couple of things because authentication is important, but it was taking up a lot of screen real estate. But basically, you configure a remote write endpoint that it will send this data to, because it already has to work with timestamps that come from Parka itself. And so it was either a metrics endpoint that exposes timestamps, which is basically almost the same as a remote write. And also, that is what our customer wanted. But in theory, a /metrics endpoint would be just as possible. Then you configure which Parka server you want to issue these requests to, and then you have a configuration where you can specify multiple queries. So you name the query, then you actually write the text of the query, and then you say, whenever you run the query, over which duration do you want all of the data to be merged over. So for example, you could say, I want every 2 minutes, I want the last 2 minutes of profiling data to be merged up, so that I can then see how this is behaving over time. And the matchers basically say, any function that matches this substring will be producing a metric. So without further ado, let's have a look at the demo. So I have a super simple Parka setup here, where this is actually scraping a Prometheus server. And as we can see, actually most of the work is collecting profiling data itself. But over here, we can see that Prometheus is actually also doing a little bit of work, and primarily it's scraping itself. So that's what we're seeing in terms of the CPU time. So all of that makes perfect sense, right? But the configuration that I used for the profile exporter is over here. So what we can see here is what I want to check is how much is garbage collection using in my Prometheus server. I'm looking at that every 20 seconds. And this is the, let's say, call it the metric name in Parka, because Parka basically has a very Prometheus-like query language. Actually, it quite literally uses the Prometheus parser underneath. This is already running. So now what we can do is we can pull up our Prometheus server. And what we can see here is this metric, right? We can see, let me make this bigger, profile exporter cumulative value, and we can see the function name is exactly the one that we were filtering by, right? And so now we can actually see every 20 seconds how many CPU samples we're observing in the profiling data. So that's super cool, right? Like now we can say, okay, I want the TSDB path in Prometheus to only use this much of the CPU resources. Or this could theoretically be done for memory as well, right? Like I want to say, okay, the memory of this particular process is not supposed to be using more than X amount of megabytes, right? And so now we can actually observe this. But what's much more important typically is I want to be able to say this is not using, a number of CPU samples is not super useful. I want to be able to express it's not supposed to use more than 30% of the CPU that the entire process uses. So this is exactly what this other metric is for. So we can divide it by the profile root cumulative value. So now we can see, wow, actually, sometimes the only thing that this Prometheus server is doing is garbage collection, right? Now, this is an example Prometheus server, right? Like, it's scraping itself. This is not like a dunk on Prometheus or anything like that. But the point is, we can actually now quantify this. And when we have a good idea about how our application is supposed to be behaving, we can now understand this pretty much down to the line number, right? And so we can be very exact about all the experiments that we're driving and evaluate whether they're actually working in the way that we intend them to do. So that is pretty much it. So what we've learned today is that we can go from metrics to profiling data with metadata, and we can go back again using a profile exporter. And that's it. Thank you so much.
All right. Do we have questions?
Just get the microphone.
Yeah, this looks very exciting. Can we use the profile exporter for anything else other than Parka, or is it Parka specific?
So at the moment, it uses the Parka API to issue the queries, so it is specific to that. But theoretically, we could build anything that it's possible, but it would require some knowledge of the underlying like data source. But yeah, theoretically possible.
Sorry, I forgot the question.
I'm here. I'm just curious, like, what's the consideration of like creating profile exporter instead of maybe having that as feature in Parka itself? Maybe you can have that as configurations, because we probably don't want to have more exporter. But
yeah, great question. So it is something that we've considered, but honestly, this kind of grew out of customer interest initially, and maybe it's something that will eventually work back into the Parka project. But Parka really only cares about profiling today, right? And it would be opening this huge kind of worms that like everybody's going to want to do, you know, arbitrary PromQL queries on all of this data. And while I think that's all super useful, it's just, you know, would very significantly increase the scope of the Parka project today. Maybe it's something we'll do in the future, though. I think it's certainly very interesting.
It's me? Okay, now I remember. Sorry. I'm interested in how complex is the setup. Like, you mentioned that you are helping a customer, and how fast could the customer adopt that? Like, I feel like people with experience would have easy understanding, but someone that does not understand profile very well, does not understand metrics, how to connect everything, it sounds a little bit complicated.
So I think the big leap is to start using continuous profiling. Once you do that, this is very, very easy. As a matter of fact, this whole profile exporter is maybe 150 lines of code. So yeah, you're right. It's really mostly about this company was already doing profiling, but they found a bunch of limitations with regular profiling, basically everything that we talked about today. But now they're like, okay, we actually understand our profiling data very, very intimately, and we want to make sure that the quality of our software continues to, you know, stay as high quality as we want it to be. So, granted, this is probably something. This particular use case is probably something that, you know, more advanced organizations are going to employ.
Yeah. Sorry, I have a question. So my understanding is that you cannot really get the metric for every function of your program, right? Because you will get a problem with the labels. And let's say you are looking at a specific function and you get a cumulative time that is big but a flat that is small and you don't expect that, then have you considered doing something like reconfiguring on the fly the exporter so that you could like look in function deeper so that you get an understanding on that?
Yeah, super good question. So something else that we've actually done in the past is we've not made this like a remote write where we ingest the data into a Prometheus, but we actually offer a remote read endpoint where a Prometheus can, ask a Parka server, give me metrics about all this, and Parka just kind of internally says, okay, I'm going to pretend all this profiling data is all metrics. That's like insanely high cardinality metrics, but I'm just going to serve you whatever you're requesting, right? Theoretically, that's where we want to end up, but it's a very hard problem to solve. So, baby steps. But it's a really cool idea. For example, with memory profiling data, you would all of a sudden see like the cumulative value of probably the subsystem that has a memory leak. You would very obviously see it growing, right? And the troubleshooting time would very dramatically fall by doing that. So definitely something that we want to explore further.
All right. I don't see any other questions.
Right.
Then thank you, Frederick. And
Thank
we
you.
are back in 4 minutes or so for the next talk.
Unrehearsed talk, exactly 20 minutes.
Yeah. I'm pretty proud of that.
It was exactly 20 minutes.
Yeah.
Should I give you back?
No, no.
I keep it and then I do the same.
Yeah, okay. For the next one. You're already here and you're mic'd up and everything. Perfect. It's so easy. You all make it so easy for me.
Got the memo.
Yeah, apparently.
Kind of got it.
Yeah. Do you do a show of hands of who's running Kubernetes or something? Okay, because then I can.
Big fan.
Okay.
So what?
Yeah, I can do that just for the introduction of you. Yeah. Okay. I just didn't want to steal it. Yeah. Yeah. I mean, it was mentioned a lot, but.
Yeah. It's a little bit now.
Yeah. Right. Yeah. It's such a growing ecosystem still.
Already short enough period.
Right.
We had to get rid of so much stuff, very basic, and then okay, that's very fun.
Yeah. Once you like start talking and you like go into some details and stuff, yeah, you have like thing rather quickly pushed. Two more minutes.
Organization is pretty good.
Yeah. Thank you.
Timelines that we have good breaks that are not
Right.
cut short.
Where's Richie? I don't know. I don't know if Richie or not stole it from Julius, but I mean, PromCon, as you heard earlier, is like 6-7 years old.
Yeah.
So
You're good
follow.
up at this point.
We just followed whatever they did and copied all the like Everybody got so quiet all of a sudden. Are you expecting the next talk? All right, quick show of hands. Who is using Kubernetes? Jeez. All right.
Okay.
So everybody wants to save some money running their cluster, and I want to do that as well, so I'm looking forward to the next talk, as always. Yeah, take it away.
Yeah, thank you. Hello, my name is Eric Sommer. I work with Grafana Labs at the platform team. And it's good that we cut the intro talk to Kubernetes short, because everything knows it already. That's good. So where's your money going? And this should really be the beginner's guide to measuring Kubernetes costs. First, what can you expect from this talk? First, when you run Kubernetes on a hyperscaler, you typically get at the end of a month a bill. It will typically doesn't match the metrics that you see in your Kubernetes cluster, and we will get to the point why that is maybe. We will get to a point where we can build up a mental model of how attribute costs in a Kubernetes cluster. And because of this PromCon, there should be some PromQL. And I like to finish up with some shortcomings and maybe some ideas where to go next. So, sorry. Sorry. At the end of the month, you get the typical bill from your CSP provider of choice. And what happens to us a lot is that the finance department then comes around and asks us the question, why have the costs doubled? Not doubled all the time, but why are there increases? Typically, you can't see that directly from the bill. There are some pointers there. You see compute instances, some abstract numbers, and some would say they are abstract by design, if you want to be nasty. So the next step is maybe you go to the Cloud Explorer of the CSP. Maybe you have attributed your workloads nicely with some tags, you can filter it down, and you come to the conclusion, okay, it is a Kubernetes cluster that has increased in size. But what you not find here is something, informations like namespaces or anything useful from what you know from your Kubernetes cluster. So next step is, of course, you go there, what you know, metrics. But the bad thing is it will not correlate. Metrics are typically not showing you, it can show you, of course, how many nodes are there in your Kubernetes cluster, but that we did know already from the bill, but not which workload typically was responsible for that. Only some usage pointers and stuff, but not how much money by which change was caused. And this makes you sad. And nobody wants to be sad. So, to recap, the problems are we have typically a disconnect between the billing statement and the metrics that we see in our Prometheus. We have the need to attribute some costs of our workloads that are running in Kubernetes. And optimally, pinpoint is down to the namespace level, because we all use namespaces, right? We not just run everything in default. I hope so. On top of that, when we run a company with different teams, different services, we like to attribute for the teams their total cost of ownership. So for the money that you make, how much did you cost us? And we like to say this also on a service level, as accurate as possibly. So let's take a step back and go a little bit to the theory. What actually is spent? So the money that we have to give to whoever provides us with our compute. It's a pretty simple formula. It's just usage times rate. Sounds simple. So what is usage? Usage can be, in the cloud context, CPU cores, memory, transmitted network traffic, stored data, or even more abstract services in an AWS world. Every one of these usage
points will have some sort of rate. It is typically something like dollar per hour for CPU cores or for memory, or if you store data, it is something like dollar per gigabyte, also sometimes per hour. And for network traffic, it will be something like dollar per gigabyte. So let's don't look at the whole month. That's maybe a little bit too wide of a time. Look at a typical day and imagine you have a typical web shop. You will have some usage in the morning. You will have some heavier usage during the normal hours when people are shopping. And you will have lighter usage in the evening, and then you scale down and your cluster gets, in the optimal case, back to 0. What we will see from a billing perspective is that during the day, on a per hour basis, we had costs for memory and we had costs for CPUs. If we break this down a little bit more, we can chunk this into usage units. So every green box here represents usage of a CPU core, and every yellow box represents a usage unit for some memory. Associated to every one of these boxes on an hourly basis is a typical rate, dollar per hour. Pretty easy so far. So when we now want to know what we did spend over the day, it is simple as that. We just have to sum up the whole day. CSP will do that on a more granular level than hourly basis normally, but for our theoretical point, it is enough to say, yeah, just sum it up. Now, approach the problem from the other side. This nice little web shop that we have a lonely little web service. It needs some CPU, it needs some memory. Let's focus for this talk just on the compute. There are more resources, but most of the costs will be associated to compute, and that's a good point to start. The important thing to have in mind is we will always talk of requests of this pod. So this is not actual usage, it's not limits or anything like that. It is requests that you tell the Kubernetes clusters you need for your workload. So, as the chance has happened, this little web service found itself a Kubernetes cluster to schedule. For the start, it's empty, so our web service gets scheduled onto that. The node pool for that has a pretty typical size, 8 CPU cores, 16 gigabytes of RAM, so our little web service only occupies 1/8 of that. Important to know, we will get built for the whole node, for all the green space that we see is now not used. So, but luckily, the team that deploys this web service is ready to scale out and will fill up the rest of the node with the other services. But we are not done yet. The team is still further progressing in the scale out and want to have another 9th replica. At this moment, the autoscaler of our Kubernetes cluster will kick in. We'll say, hey, I need another node. We'll get this another node and schedules the next service onto that. And again, we will get built for this second node of our cluster, even if we're just using a small portion of it. So that are the both sides from where we have to approach the problem. What we know already is what we get built for. There are some nice dollar numbers. What we not know yet is, from another side, what is it cost from a Kubernetes and Prometheus perspective to have these nodes and to have this web services provisioned. So we have to answer the question, how to measure actual usage. And the good thing is, you will probably have this metrics already in your cluster. Most of us will run something like kubestat metrics to know how much CPU is used by our workloads and all other important information that you need from Kubernetes. So we need the information how much CPU and memory are used by our nodes and how much CPU and memory are used by the request of the workloads. And simple as that, yeah, this matrix exists. It's kube node status capacity with some handy labels here, cluster, resource, and node. And for the workloads, we have kube pod container resource requests, cluster, resource, node, and in addition here, as we know where the container is running, in which namespace, we also have the label namespace. So, going back to the simple formula that we saw at the beginning, we have to make a sum of usage and rate. Let's look first at the nodes, because we want to have a picture over the whole cluster. Okay, it's pretty simple. Kube node status capacity. We don't sum up by anything yet, because we are just interested in what is the picture over the whole cluster. And now we're at the point where we say, yeah, okay, that's a nice graph. I know now how much CPU cores are used by the complete cluster. I could do that before. But where do I get this rate? The next point will be a little bit disappointing, but you can just estimate it as a first step. Your provider will give you typically the price per machine that you're supposed to pay. It depends on the machine type, it depends on the processor type, it depends on the region where you want to have it. When you are with GCP, you can also get an hourly price for the virtual CPU core per hour, and same for memory. For AWS, it's a little bit more difficult. There's only the price for the whole machine. But you can calculate from that down pretty easily. So we can estimate roughly a price from that. So in our example, let's say we have N2 machines in South Carolina, and they cost around 3 cents the CPU core per hour. So we can just fill that in pretty easily. We divide it by 60 because we want to end up with a metric that is saying cost per minute for a reasonable granularity. And easy as that, we arrive at a metric that can say for us, okay, your cluster is costing this much money per minute. Yeah, let's fill that in a little nice recording rule. Call it cluster, that's our granularity, cost per minute sum. And the important part here is we have to add a label for the resource that we can have a breakdown on resources later on for this metric. You can now do the same thing pretty easily for memory, and you're done for the complete view on the cluster. But that isn't the point where we want to stop. As we saw earlier, we want to know which namespace is actually causing some increase in costs. So let's go a little bit closer to reality. We will not have only one service in our clusters. There will be some daemon sets. There will be some chunky Prometheus that fill up the whole node. We all been there, let's be honest. There will be push gateways, some alert managers, and they all are associated to different namespaces. So now the next question for us is, which namespace is the expensive one? Which namespace is increasing? For this, we are now interested in the workloads and which impact they have. We have to go back to our simple formula, sum, and this time we want to know it by namespace, that we have a metric for every namespace. This time we are interested in requests, so we go with this kube pod container resource request matrix this time, and this will again get us some metric on this much CPU cores are you using per namespace basis. We learned earlier, rate is pretty simple to get. Just go to your provider, get an estimation, and fill it in. And easy as that, you arrive at a point where you can say, okay, this namespace is causing this cost for my cluster. Now we think, yeah, that's it, right? You don't need to know any more. If you get these two metrics, and now you can say, okay, I just sum up all the namespaces, and it will be the same sum as the view on the complete cluster, and I'm done. Well, no. There will be stuff missing, because, again, sorry, I skipped one slide. a view on the complete PromQL query. Pretty simple again, just sum it up by cluster and namespace, and you're done with that recording rule. But a little bit more reality again. Kubernetes will try to do a good job for you bin packing all your workloads nicely on the nodes so that you don't use too much nodes. It depends on the scheduling strategy, all that stuff, but there are topology constraints, there are workloads that shouldn't run on the same node. You will have empty space on your nodes. Empty space for which you are billed for by the CSP, but that you're actually not using. Internally, we call it just idle resources, because you pay for it, but you don't use it. So to get the whole picture, you have to know what are these idle resources and how much are they. This time it gets a little bit more complicated because we have to combine the knowledge from the first two queries together. Because what is idle? Idle is the capacity that we get and minus the requests that we actually use. Again, times some rate that we estimate. Do it on a node basis. So first, sum it up by node, the capacity, like we saw earlier. Also sum up by node for the requests, and then you can make the subtraction on a node level. To wrap this all up, sum it up for the whole cluster, and you get a view for the cost for the idle resources on the cluster view. The recording rule for this looks pretty similar. It's not so much more complicated. What we do additionally here is we add another namespace label for idle. We are going with underscore underscore idle underscore underscore. We hope to this day that no product team has the idea to name his namespace this way. I'm pretty sure. And then we have sort of a virtual customer of the cluster that has associated all these costs that no real customer is using. And we can say, okay, now we have the complete view. We know what the cluster is cost, we know how much the requests are costs, and we know what is wasted, so to say. So there are some shortcomings to this. First, this approach really works only when you have a pretty simple cluster with maybe just one node pool, only one machine type. When you start to have different machine types, for example, different processors, then you have different costs associated to every one of these nodes. To get an estimation then gets difficult because it changes depending on the number of nodes of each different cost unit. And then the approach of just estimating it gets to a problematic point. This only takes into account compute resources, so only CPU and memory. We also extended the strategy to other cloud resources like storage, so block storage. My colleague Fedor Dikarev will later on talk about this in a lightning talk, real quick in 5 minutes. That's a challenge. But for now, we're only looking at compute. As mentioned earlier, not all CSPs will break down the costs for you so nicely like GCP does it, but with some little napkin math you can get there. And pretty interesting point, this doesn't take into account saving plans. So we tell the teams and the overview only for the bill before it gets reductions. The ratio behind it is if you take reductions into account, you get a skewed view over time. We want to be able to have January and December and compare together and say, okay, your total cost of ownership reduced. If we have a new savings plan in the middle of the year, this view would change dramatically. And you can't compare it then anymore. And plus, it is way more difficult to take savings plans into account. So that's another reason. What can come next? As we saw, different nodes can have different costs. And so this approach of just estimating the rate will come to a point where it's get difficult and you have to do something else. There are products out there. One example is OpenCost, which we use internally, which will produce this cost metric per node for you. So they actually look up, okay, that's the nodes you're running on a CS provider level, and this is how much you get billed for it. They pass the API of the provider for that. Look at the API, it's fun. It's really concise. They do a great job at that. And they will give you, for every node, a metric, how much that costs for you for every resource there is. So we can do this again. This is a recording rule that we saw earlier for the resource request, so on the container level. And this time we try not to estimate the rate. We want to try to have a pinpoint on the node level. And the nice thing is, PromQL can do that for us. It is a simple join on the node level. And if we now imagine we have a metric like node CPU hourly cost divided by 60, again, we want to have minutes, then we can join every container to the node price it has individually and can sum this up again on the cluster and namespace level. And as it didn't get better as a nice join in PromQL, I thank you all for your attention and happy to hear questions.
No questions? Okay, one question. Because you all want to save money on your clusters, no?
So the first version that you have without OpenCost, it seems that you even mentioned that, but it only works for homogeneous environments.
Yeah.
However, does the version with OpenCost, where you have a bit more data pre-computed by OpenCost, allow you to do the same with heterogeneous environments?
Yeah. So when you have different node pools with different machines, which cost different things, it will say on the node level how much this specific node costs. And as you know, for the container on which node is running, you can say, okay, this node, this costs, multiply. And so as a team, when you make the change going from a normal Intel processor to ARM, that there should be a benefit because ARM is typically cheaper. You get scheduled on another node. This node has another price, and so the calculation for this workload changed, and this gets reflected in the total cost of ownership. Yeah, it works.
Hi. So I did something similar for a previous company where I had to narrow down the cost to a particular query to build like the business model of the SaaS service. And what I've noticed too is that sometimes you have namespace or services that serve other services. So you need to take this into account to redistribute the costs on those services. So basically, we had like a kind of a shared pool that was like shared.
It's this: when you run a platform, who pays for the platform? In a former company of mine, they tried to do that. It's always a difficult thing to do because then you get into the arguments, but I only using 11% of the platforms. Another team is using way more. And we actually don't do that. We have the platform team. It has its own costs. And as long as you don't say, okay, but where's the revenue from the platform? Sorry, everything is running on it. Isn't that enough? If you don't have these discussions, then you're fine. And I would personally not recommend to do it, but if you get to a point where you say, okay, what part of the platform are you actually using? you can do something like, okay, look at the whole cluster. This namespace is using so much resources, so it uses so much percentage of the platform. But if you run a Prometheus, it's also a very expensive endeavor sometimes. Yeah, it gets difficult.
It was. Hi. Here.
It is difficult to see here. It's a lot of light.
Light is light. It's great. You showed a situation where a pod can run alone on a node, can occupy the entire node. And this can happen kind of spontaneously, but can also be triggered by scheduling constraints.
Yeah.
So would you attribute the cost of that node to the service, or would you just say the idle capacity is just idle and it doesn't have any cost attribution?
We don't associate the idle resources of the lonely running pod on the node to a service, because most of the time it's not running there alone. There are some daemon sets, that's also namespaces that are costs. We handle it this way, that the idle costs are the objective of the platform team. So our goal is to reduce that and make it that there's not so much of it. It's difficult because at some point you have the problem between cost reduction and actually keeping the services alive, because it's get harder to run if you are more constrained in resources. But yeah, for our team, it is our objective to reduce this cost, and there are good projects to do that. If you run on AWS, try Carpenter. That's a very good idea. And also GCP have some things they did, like the optimized scheduler, that will get you a good way further to reduce this idle resources. But to attribute this to a certain namespace, maybe it can be done, but I would say it's not a good idea.
Hi, thank you for the presentation. I'm interested in, like, for CPU and memory, that's kind of straightforward, but what about egress and ingress? Because the rates differ for, like, routes to different zones or regions. Is there any product which is trying to address this, or?
We don't do that yet. It gets way more difficult with network. The first thing is you have to measure this reliably on the namespace level. We are not there yet. And mostly we try to avoid cross-zonal traffic because it is expensive. But we want to improve this in the future, to measure this and have also costs for this. Yeah.
Thanks.
Over here. So I have a question. So you showed some recording rules earlier. Does that mean that you also have alerting rules to alert on costs, or no alert rules?
We thought about it. It's difficult, again. You can have something like, okay, the cost of this cluster doubled overnight. That's alertable. Is it though? When the cluster is new and it actually scales out, someone gets woken up because, it actually scales out. Most of the incidents that we saw from there's some cost explosion were also alerted by some other mechanism from the workloads. So at this point, we didn't see the necessity to alert on costs, because most of the time it will be false positives for just natural growth. So no, we don't alert on costs yet.
I have a question. So what is next after identifying the namespace or applications that consume a lot of resources? Are we going to go after the teams, right, to fix it?
We mostly see our job as informing the teams. So we give them the metrics to build their own TCO. We also have metrics for usage of their service. So it boils down to some metric for when you have a metric service, for every series, we spend so much money to host it. And this is a metric that they get measured by to lower that. So most of the cost reduction is actually driven then by the teams itself. it is just not a work that can scale pretty well for you as a platform team when you start to chasing after individual teams. And so informing them, giving them the tools to calculate their own TCO is from my perspective, the way better approach.
And do you use like the VPA, like the vertical port autoscaler, like to give some insights about applications?
We use it for some applications. There are benefits. From my view, the downside of the vertical port autoscaler is it scales for you silently a workload until it reaches the complete capacity of a node. And then you have other problems. So we don't use it too much. Most of our scaling is done horizontally.
Yeah, but at least just to get some recommendations, right? To like some recommendations for CPU and memory parameters to applications, like not to tune it like automatically.
Yeah, it's difficult to say that on a very generic level because it very much depends on the workload itself. There's again, the teams know their products best, and we inform them how much this costs, and they can decide, okay, we want to trade in reliability for cost reduction, but this is not something that you can say from the outside, at least in my experience.
Okay, seems like a great discussion to have during lunchtime now if you want to continue.
Happy to have.
Here's a speaker gift. Thank you so much for speaking. I hope no one spends a single dollar anymore unnecessarily on Kubernetes clusters. I'm sure. But we'll have lunch for an hour now. We'll have the duck breast and ragu and the Königsberger Klopse, as well as some salad. Next door, you know the drill. We'll be back in an hour. Enjoy.
So, hello. Welcome back from the lunch break. So, I hope you still have some energy left after lunch for listening to the next talk, because it's a really exciting topic. Welcome on stage Krajo, who will tell us everything we need to know about the streaming PromQL engine. So, thanks, Krajo. Take it away.
Thank you. Hi there, my name is Eduard Krajovic, but everybody calls me Krajo for obvious reasons. And I work as a software engineer at Grafana Labs. I work on Mimir and currently mainly on native histogram support. And I see people filtering in, so I'll say a few words about native histograms first, which is not the topic here. But everybody talked about native histograms, so I feel like I should mention it that Mimir also supports native histograms ingestion, both through Prometheus remote write and OTel, so you can send exponential histograms as well. And you can try it out with Mimir. In Grafana Cloud, it's still in preview, so you need to send a support ticket, but we can enable it and you can try it out. But that's not the topic. I will talk about yet another streaming Prometheus engine. First, a few disclaimers. Actually, this work is very, very experimental. It was done by one person during a week-long hackathon at Grafana Labs. And actually, that person wasn't me. So it was done by Charles Korn, but unfortunately, he couldn't make the conference. So if there are some mistakes, then it's probably me explaining it wrong. All right. So let's get into the problem that we are trying to solve. So I'm going to talk about this problem in the context of Mimir. Mimir, for the purposes of this talk, is a scalable microservices architecture time series database built on Prometheus. It provides Prometheus API compatibility. And it's great at ingesting huge amounts of time series. We demonstrated that you can ingest 1 billion, that's a billion with a B, time series in a single cluster of Mimir. However, it could be a little bit better at acquiring huge amounts of data. And in particular, we'll look at a component called Queryr, which is the bit that actually houses the PromQL engine. And this is a graph of the memory consumption versus time of our queryers. This is from an actual production cluster. And you can see that there's kind of a steady state, but there are like peaks of double the memory use of the steady state. And this is kind of an issue because we are paying for the memory that the maximum memory that we use, so basically we are paying for the peaks, but we are actually not using that much memory all the time. So that's kind of wasted. And the worst part is that memory isn't really elastic. So when you go over the memory limits, your pod will be killed, and in the best case, the user will notice that the query runs slower because we will retry. But in the worst case, it will just not work, and you get to 500. So that's not ideal. So the question is, why does this happen? And let's look at a very simple query example where this comes up. Let's suppose that you're running the sum over some metric selector as a range query. What happens in the PromQL engine, in the vanilla engine, is that the engine will load all the samples from the metric selector, and then in the next step, it will calculate the sum. And basically, the first operation, this loading of all the samples, is the part where we run into this issue that we can load so much data. Remember, Mimir is distributed and scalable database, so we can load huge amounts of data. This is where we can run out of memory. Actually, this isn't a new problem. So we already know about this, and Mimir has some strategies to, already has some strategies to mitigate it. First of all, if we are looking at this query over 5 days, so the range is 5 days, our first technique is that we are going to split up the query onto days. So we will run some metrics on the first day, second day, first day, and we can distribute this over many queries so that we are not using the memory in one place. The second technique is actually query sharding, where we are taking advantage of the basically the properties of sum, that you can create a sum from the like parts of the like sum of the parts, and we are sharding a series and then creating sums and sum them up. And the third thing that we do is that when we are loading series into memory, we do something called chunk streaming, where we are not loading all the chunks, the underlying physical storage of samples all at once, but we are loading them in the stream. And this chunk streaming actually enables us to reduce memory utilization in queries to around 20–30% in some cases. And then the final line of defense is limits. This is the bit that nobody really likes. We have to configure them, and then when users run into them, they might get some really cryptic error messages, like chunks limit reached. So this is not ideal. We'd prefer to just actually do the query and not run into these limits. In summary, we are doing a lot already to mitigate the effect of loading too many series, but we could do even more. And at this point, some of you might be asking yourself, so what about Phanos' streaming engine? Last year, Philip and Bartek demoed Phanos' new PromQL engine, which computes results by streaming results by time step. So basically, they are streaming by time, and it uses parallel programming to achieve impressive query latency. And indeed, we did run tests and try this out. We did some experience. And it turns out that, unfortunately, for our use case, in itself, it's not quite the right fit. And I will explain the next slide why. So there are a few main reasons why this is. First is that, according to our statistics, something like 90% of the queries that we see in production are actually instant queries, where there's no real time steps. Think about alerts, recording those, summary numbers on dashboards, etc. And then a big benefit of the streaming by time step is splitting up by time, but we already do that. So if we are looking at long-range queries in multiple days, we already have the splitting by day, so the time splitting. On the other hand, on the flip side, what we do see is sometimes queries loading huge number of series in one step, in one time. And so think about monitoring Kubernetes. If you have a large Kubernetes cluster, your time series could number in hundreds of thousands or millions even. And so in this case, streaming by time series doesn't help us too much, because even in one point in time, we can load a huge number of series. So if we could combine this splitting by time, splitting by days, and then streaming by series, then that would basically put a cap on how many series we load at the same time, and put a cap on how much memory we use. So to summarize, streaming by time step isn't quite right for us, but we do believe that streaming is the future. And here, but just a different kind of streaming, streaming by series rather than by time. So going back to the example from before, the sum. So this is exactly the same sum as from before, but this time we are going to do a different strategy. So this time we will load the first time series and then add it to a running sum. And then load the next time series, add it to the running sum, and so on until we loaded all the series and created the sum. And this strategy can work even if the expression is more complex. We can make this recursive, so basically stream the result of the sum as a series into the next operation. Also, it can work if you have a group by, so you say something like sum by cluster or sum by node. We just have to make sure that when we are creating the running sum, we know which series goes into which group. And then once we collected all the series for a group, then we can emit that sum for that group. Yeah. So why do we think this is better for Mimir? It all comes back to peak memory utilization, right? This kind of strategy aligns well with what we already employ, which is streaming by chunks of series, and then which means that we don't need to load all the chunks for all series into memory. Also, the peak memory utilization of such strategy is determined by the cardinality of the output. So basically, in this case, the coordinate is 1, we just get one sum. If there's a group by, then the cardinality is how many groups you have, and that's going to be directly proportional to how much memory you use because of the running sum. And furthermore, because we are doing these things over and over, like load a series, add it to the sum, load a series, add it to the sum, we can reuse that memory and kind of take away some pressure from the garbage collector. So this is basically exactly what Charles has prototyped, and meaning that he wrote basically a full replacement of the PromQL engine, but obviously he didn't implement everything. He just implemented the metric selection, the loading, sum, and rate. But it was enough to run some measurements already. So let's look at some measurements. I know that people tend to always look at the colorful bits, so I'll explain that first. So the measurement was done like this. You take Mimir, and it already has the Prometheus engine, but you can switch it out with this new engine that Charles wrote. And also you can swap it out for the Phanos time slicing, time step streaming engine as well. So that's what the measurements are. The red one is with the Prometheus engine, the orange one, the middle one is with Charles's prototype engine, and then the blue one is as Phanos. And on the left side, you'll see the peak memory utilization, and on the right side is the P95 latency. So the measurements were run on a few different use cases. Actually, this use case is the kind of the worst one for this, almost the worst one for this engine. This is when you are just straight up loading a bunch of series. In this case, we're loading 1,000 series over 1 hour range, 15-second step. This isn't terribly useful because, like, how are you going to show it in Grafana, for example? But still, it's a good measurement point. So here you can see that actually the memory utilization is worse than both Prometheus and Phanos, and also the latency is worse. And that's because, well, A, it's an experimental thing, then B, it does introduce some overhead into the processing. But having said that, this is experimental, so it could be optimized. And actually, in the worst case, we could default back to the original engine if we cannot optimize it further. So it could be on par with the Prometheus engine. So let's look at a better case. This is including sum and the sum going into some few groups. So this is 100,000 series into 10 groups. And here we start to see the benefits of streaming. The memory utilization is like 1/10 on the others, and on the latency side is still a bit slower than the others, and especially Phanos. We think there's some way to improve on the latency, but remember, our main concern at this point is memory, actually. So let's look at another. Yeah, and just to drive home this idea of the memory utilization depending on the output, basically the cardinality of the output, here's a graph of memory utilization on the y-axis versus the number of series that you put in. And you can see that basically the streaming by series engine flattens out quite soon and stays there because we are not loading all the series, we are just loading what we're actually adding to these groups. All right. Here's another example. This is an instant query now, so this is not a range. This is 100,000 series, 10 groups. And actually, this is very important for us. Like I said, 90% of the queries that we get are instant queries. And here, the memory utilization is night and day. So streaming by series has like 35% memory utilization, less memory utilization, and less latency. So this is where you can see that streaming by time step doesn't help that much because there's basically just one time that we're evaluating for. And let's look at the scenario where we would expect the streaming by time step to shine. This is a long-range query. This is 12 hours now, not 1 hour. But we had to reduce the number of series because actually on a laptop, it was too much, like 100K series for 12 hours. Here we see that the streaming by series and by time step performs similarly, but the streaming by series is still a little bit faster and uses less memory. And however, well, all is not like great. This is again experimental, and there are some cases that trip this up. So if you look at a query like this, it's kind of a join on node, and if you look at how Prometheus will break this down, we'll get the one sum on one part of the division and the other sum on the other division. And the problem is that when we are streaming the results from these two sums, there's no guarantee on the order of the result, like what's the order going to be. Meaning that basically at the division, we have to wait and buffer the partial result until we get the corresponding result from the other side. But note that even in the worst case, this is just going to use the same amount of memory as before. But if we are lucky, then it will reduce the memory used because we will do those matches earlier. Yeah. So what's next? This is still an experiment, and the results are looking pretty great, like very encouraging, but there's plenty more work to be done. And we are going to continue investigating this, expanding the engine's capabilities, and this is something that we want to pursue further for sure, because it's addressing a real problem that we have with memory utilization. And you can check out the code. It's in a branch in Mimir. And also, there we have a blog post about the 1 billion series that I mentioned. And that's it. Thank you very much.
Hey, thanks a lot, Krayo. Really amazing. So I'm looking forward to seeing more of that in the future.
Thank you.
Any questions, anyone? Raise your arms. I don't see anyone. Any questions? Come on. Yes.
Yeah, thank you. Did you try like a hybrid approach where you do like parallelize some, like one by one, and then gather the results for your time series?
You mean parallelize?
I mean, like for the sum, like you take one time series and you sum it. You take a new one and you sum it. Do you do that in parallel or do you do that in one worker?
It's done in kind of two passes. I didn't want to go into too much detail here, but what happens is that we load the series, the names of the series basically, group them, and then we run in a second pass the, we go through each series and add it to the sum of the group that it belongs to. It's not in parallel. I guess we could do something in parallel, but like that's something to do next.
Any more questions?
Okay, then I'll have one. Did you attempt to work with the Thanos project on this?
I think, I'm not sure if there was a connection. We haven't talked about that with Charles. I assume that there was some interaction, but I'm not sure.
Okay.
Obviously, we are not opposed to it. Like I said, it's a work in progress. It would be great to combine all things and.
Right. My thought also was like in a lot of query optimizers and stuff like that. This would have like a cost optimizer for the query, right? And it would decide this particular strategy is actually better for this query, and maybe for other queries this other approach is better.
Yeah, definitely.
Well, I think like he can answer my question. It was related to it. Like, can you choose or different query engines based on the query? Like, if it's an instant query, you would use this one. But then if it has a lot of timestamps, you would go with the Thanos one. Like, I don't know. Are there any plans to do something like that?
Yeah, we want to, explore all possibilities basically at this point. So that's definitely one idea. I think another idea that came up was optimizing like how we get, in what order we get the series, and maybe do something like to optimize for the join cases, but it's early days, but definitely in the cards, yeah.
Hey, fantastic presentation. Would you have benchmarks for longer time queries and how this compares to, for example, Thanos engine? So you showed like 12 hours.
Yeah.
Would you have something for like 30 days and like a breakdown where streaming actually breaks down and increases latency, for example? Would you know this?
We haven't run those because, like I said, it was run on a laptop. But definitely, we want to do more tests with like bigger data sets. But again, in Mimir, we already are breaking down those long-running ranges into days. So basically, it makes sense for us to concentrate on below 24 hours, because over 24 hours, we are already splitting up.
I see. Thank you very much.
Sure.
So, any more? We can take one last question if there is any. Yes.
Yeah, thank you for the talk. Just one question. Are there any plans to introduce downsampling, like it's already available in Thanos, to reduce the number of samples to load in the first place?
What was the question, sorry?
If there are any plans to introduce downsampling in Mimir?
Oh, sampling.
Downsampling of the metrics, like it's already available in Thanos, like to reduce the number of samples.
Okay, that's a very good question, but I don't know the answer to that. Our current strategy is that you can use adaptive metrics to reduce your, cardinality of your metrics. Obviously, we are looking at all possibilities, and we have been looking at, downsampling and something like that, but it's not like I cannot say anything about like roadmap or promise anything.
Cool. So thanks again. It was very interesting, and we have now 5 minutes for switching the speaker, and the next talk is on configuring the OpenTelemetry collector for Prometheus. Thanks.
Thank you.
So, yeah, welcome back again. Here on stage we have now Matej from Coralogics, and he will talk about configuring your OpenTelemetry collector with Prometheus. So, welcome, Matej.
Thank you. So once again, my name is Maciej. I work as a software engineer at the company called Cralogics. We are an observability vendor. I mostly work on the collection side of things, so I deal with agents and actually also OpenTelemetry Collector, which partly inspired this talk. But in my previous work and in my open source contributions, I also worked within the Prometheus ecosystem. I worked on Thanos, but currently it's mostly OpenTelemetry, so I thought it might be an interesting combination to talk about this today. So what we'll talk about, we'll take a look at the current status of both ecosystem, where they are, how they compare. Then we'll dive right into talking about what is the famous OpenTelemetry Collector and its pipeline. We'll talk about how we can receive and export Prometheus metrics with this collector. We'll also look partly at how we can then further automate this. If you're running on Kubernetes, there is an OpenTelemetry operator that you can use. And we'll look at how this relates to Prometheus metrics as well. And we'll end up with some summary and some wrap-up. So current status, we have two projects. What do we see when we look at them side by side? OpenTelemetry, we hear it left and right, this new emerging standard and ecosystem is touting itself to be cloud native, vendor neutral. It's under the auspices of CNCF, same as Prometheus. But when it comes to its definition, for me, it's always kind of elusive because it cuts through so many aspects of observability. I cannot sum it up better as a collection of different things that are named there, but we can start from the collector, where some people see OpenTelemetry as a kind of synonym with the OpenTelemetry Collector, which is the implementation of how OpenTelemetry imagines the collection and processing and exporting of telemetry data. But it's much more than this binary, this piece of code. It's also a very robust specification that tells us how things should and should not be implemented. It comes with its own protocol for transferring data, the OpenTelemetry protocol, or OTel for short. There is a whole set of SDKs, instrumentation libraries, and so on for all the languages that you can desire. And very importantly, the data model is also different from Prometheus world. Because Prometheus, we could say the Prometheus data model is simpler and serves its purposes, but because OpenTelemetry tries to be kind of a more all-encompassing standard or project, it needs to also accommodate for other protocols. So the data model is a bit more complicated. There are more things within this model. I named some of them here, and we might go through them during the presentation. But I think the important takeaway is that we need to make a bit of a mental shift from the model that we have in Prometheus. Most importantly, storage is not part of OpenTelemetry. This is left out completely outside of the scope of the project. So this is up to you, whether you want to use some SAS offering, you want to run your own hosted solution, whatever is the format that you want to send your data there, this is left up to you. On the other hand, we have our beloved Prometheus that is near and near to our hearts, staple in the monitoring world with its well-known exposition format, with its world-famous TSDB that we all love, and which also serves as a basis for the distributed versions of Prometheus, Cortex, Thanos, Mimir. And it comes with a robust community that takes care of numerous exporters and other tools that help us streamline our infrastructure and automation when it comes to Prometheus workloads, so namely the Prometheus operator. So then why are we talking about these two? So we're here at the PromCon, and now there's this guy who's talking to you about OpenTelemetry, like what is he doing here? Is he trying to convert you? Or who let him on the stage? And my short answer is I'm not trying to convert you. I'm not claiming that one is better than the other. I think everyone needs to look at these projects and answer the question for themselves, whether they, what are the pros and cons, whether they think it makes sense to switch or not, whether you might, for example, value maybe the unified experience that OpenTelemetry brings for all the major signals, or the flexibility that comes with the OpenTelemetry collector and its pipeline, and how it allows you to maybe transform data and use various deployment patterns. But on the other hand, you might value more maybe your existing experience with Prometheus, maybe you value its stability. It's a battle-tested horse. It's been around for long enough. So I think this is up to everyone. But even as we've seen in the last 2 days, I think the overlap between these two worlds and the collaboration is inevitable. We heard a talk yesterday from Jesus and Gautam, where we learned that Prometheus also intends to become a native solution for storage for the OpenTelemetry protocol. And we've seen also increased interest from within the Prometheus community in regards to adoption or usage of OpenTelemetry. We had at least 2 lightning talks yesterday by Daniel and Hayo. We're talking about or comparing OpenTelemetry and Prometheus in a certain specific aspects. So I think that the overlap is undeniable, and I think it will only grow in the future. So I hope that if you're considering OpenTelemetry, or you're interested, or you're just curious, that I can give you kind of an introduction and high-level overview of how OpenTelemetry, when it comes to metrics collection, how it compares to Prometheus, and what is how it also functionally compare with each other. So now that we have the intro out of the way, let's get into the actual collector and looking at what is collector. So as I mentioned, this is kind of the implementation of OpenTelemetry, how it collects or receives, processes, and exports telemetry data. It's a binary. We can just call it whether it's a collector or an agent. It's something that sits somewhere in your infrastructure and collects telemetry signals. As we'll see, we'll go through the whole pipeline that we have here from left to right. So we'll start with our instrumented applications. And in this case, there's no need for change, or there's nothing novel here. We still keep using our applications that are instrumented with Prometheus, that are exposing the metrics endpoint. So from this perspective, there's nothing that needs to be changed, or there's nothing new. On the other hand, using the collector gives you also possibility to introduce some other protocols. So for example, if you would opt to instrument your applications with the native OpenTelemetry SDK, you can send metrics in the OTLP format, or you might want to use some other protocols. Maybe you have some parts of your infrastructure that are not using Prometheus, but rather some other protocols. I have a statsd here as an example. So this also collector makes it easier to receive data in these other protocols. Now the collector itself, we'll talk about a couple of different types of components that are part of the collector. I will focus on the 3 that we see here. It's the receiver, processor, and exporter. And I'll talk about each of these in a moment. But basically, for our mental image, it's just important to know that how the pipelines go from receiver to processor to exporter, and then ends up in your backend. So first of all, the receivers, as the name suggests, they receive the telemetry data, and quite simply, their main task is to translate the format that it's coming from into the internal representation of the telemetry data, which is called pipeline data, or sometimes for short pdata. So whatever the format is that it's coming in, it will always be translated into this internal representation. Then it's used inside of the collector. So we have receivers that use both pull and push-based approach. So this is again something that won't be changing from what you're used to in Prometheus. Again, we'll still see the Prometheus receiver using the pull-based approach, so it will be just scraping the data. But in addition, again, if you have some other protocols, which might be push-based. You also have push-based collectors receivers in the collector. Processors, I won't talk too much about processors, but basically they allow you to process the telemetry data, to manipulate it, transform in some ways, maybe remove some series labels and so on, do some filtering, batching, and so on. Exporters, these are then the other side of receivers. So on the other end, they are responsible for translating the internal representation of the data into the protocol that can be understood by the backend that you're sending this to. So again, if you want to send, for example, data into Prometheus or Thanos Mimir Cortex via remote write protocol, for example, we would use remote write exporter, and this will take care of translating and sending the data, also including all the other properties that are common for clients, so it can also retry or queue the data for sending and so on. For illustration, here I have a very simple, this is how a configuration of a collector can look like. So it's just a good old YAML. If you go from top to down, you see we have 4 different sections here. The first one is receivers, where we define our receiver. So in this case, we want to receive data in the OTLP format. We're exposing 2 endpoints, one for gRPC and one for HTTP. And we also define processors that will want for us to batch the telemetry data. And lastly, we have a simple debug exporter defined, which will simply put out the data on a standard output in this case. So if you look at the last section, services, and under that the pipelines, you will see that we're defining pipelines per each signal. So we have, in this case, we want traces and metrics. So as you see, the telemetry data will go through the pipeline from the OTLP receiver, then it will be batched by the processor, and lastly, it will be output to the standard output with the debug exporter. And one more example here, just for example, if I decided to also add the Prometheus exporter, so there you can see I have it defined under the exporter section. And again, now just if you look to the very last part of the service section, the metrics pipeline, again, I want to receive the data in the OTLP format, I will batch it, but in this case I will export it to both for the debugging purposes, to the standard output, and also to the Prometheus. So the collector and the pipeline gives you a power to kind of mix and match different types of receivers and exporters or protocols, or maybe you might want to send the telemetry data to different backends supporting different protocols, or you might even have multiple pipelines per each signal. So it really gives you that flexibility and those possibilities of manipulating the data and sending it where you want in whatever format you want. So then we'll look at the particular receivers and exporters that are relevant for Prometheus. We'll be looking at the Prometheus receiver and related simple Prometheus receiver, and kind of a special type of receiver, or it's called receiver creator. And then with exporters, we'll look at exporter and remote write exporter and see what they do. So Prometheus receiver is actually nothing too complicated. Again, it's intended to be as a drop-in replacement for your Prometheus. So if you take a scrape configuration from your Prometheus and you put it as a configuration for the Prometheus receiver, it will be able to understand it. It's kind of a one-to-one, it's not even translation, it will be able to understand the same configuration. So the receiver actually reuses the same components for scraping as Prometheus. So all the features that you want, you have available, like service discovery, authorization, relabeling, and so on. And if you opt for using the simple Prometheus receiver. This is kind of a wrapper around the Prometheus receiver itself, but is used for single target. So if you look into that, it's like a simplified version of the Prometheus receiver, so it might be interesting for you. Now, just again, for illustration, you can see nothing complicated. This is just a portion of the config that I was showing previously. So this is just showing the receivers, and we'll just define the Prometheus receiver, and you can see the scrape config must look familiar to all of you. We define some jobs. We have one static job that's scraping the collector itself, and then we're using Kubernetes service discovery. We have some relabeling configuration there. So all familiar. Receiver creator, I think it's an interesting possibility also within the collector. It's not a receiver by itself, but it can conditionally create other receivers, and therefore also Prometheus receiver at runtime. And this is based on discovering networking endpoints discovered by so-called observers. Observers are another component that are part of the collector, but they don't deal with the telemetry data themselves. They are just serving this purpose of discovering those endpoints. So whether you use Kubernetes, Docker, or you just run it on your physical host, there are observers available for different environments. And then these leverages rules and variables that can be used to conditionally define and run the receiver. So here I again took an example from the collector repository, where you can see that we define in the receiver section, we would now define receiver creator, and we would want it to watch for the Kubernetes observer. And again, in the receivers, we define receiver as previously. So we kind of have now two levels of configuration for the receiver. It's becoming a bit maybe less clear. But then in the Prometheus simple, the definition of the Prometheus simple receiver, we have the rule, and we see that under this rule, we would want it first to look for the type to be pod, so this kind of corresponds to the endpoint type. So in this case, we're looking for pods. And if the pod has an annotation, prometheus.io/scrape, it will create the receiver for this endpoint. As you can see also in the configuration, you can reference, you can also conditionally reference some variables or some values from your annotations and use them to set the endpoints and other configurations. So it can be interesting for some use cases. The other side of the collector, the exporters, there are two that are relevant to us. There is Prometheus exporter and Prometheus remote write exporter. The first then, the Prometheus exporter, this exposes metrics in the Prometheus format for scraping. So this will expose them on the metrics endpoint as we're used to. And it has, besides other configuration, it has configurable metric expiration. So depending on how long you don't see metric coming in, it will unregister this metric, and it will not show up in the metric endpoint anymore. The second one, the Prometheus remote write exporter, is again the configuration is very similar to what you would see in your Prometheus agent or other solution you might use for remote writing. So it just simply sends remote write compatible backends. There you have some options to fine-tune your remote write, how it queues the data. It also supports WAL, although write-ahead lock, although I think currently there are some issues around it. So if you look into that or if you use it, then be mindful of that. And one important caveat is also, this goes back to the differences in the data model, especially if you would be looking into ingesting metrics that are not Prometheus native, maybe that are coming from other protocols. There are some types of metrics that are coming from OTLP that cannot be very well represented in Prometheus, or there is not a good way to do this currently with the exporter. So these data points will be dropped by the exporter. There are some common additional aspects that relate to also the difference in data model and how the data is transformed internally in the collector. Some of this were already mentioned here, but you should be aware of name and label normalization. So there are differences between, for example, the OTLP protocol and the OTLP format and the Prometheus format, where the OpenTelemetry uses dots to kind of denote the hierarchy in the name of the series, whereas, as we know, Prometheus uses underscores. So there is a whole package and a whole way how things are normalized for Prometheus. Another important thing is resource attributes, which also relates to the OpenTelemetry data model. Resource attributes are basically attributes that belong to an entity that produced certain metric or the resource in the parlance of OpenTelemetry. So for Prometheus, maybe we can make this analogous to the target. So these are certain metadata, I would say, about the resource that is originating the metric or the telemetry data. And here I have an example. Below you see this is how it would look on the debug exporter if I dump out some resource attributes. So this can be anything from, like, you see, if I'm running there in Kubernetes, I have Kubernetes pod, UID name. If you would run on a host, you might have the name of the operating system there. If you're running in cloud, you might have your cloud provider name, region, whatever it's related to those resources. Now the question is, how do we deal with this in Prometheus, right? Because we don't have this notion of resource attributes in Prometheus, and as was already touched upon yesterday, we can either you have possibility in collector either to send this into Prometheus as a target info metric, which is a special metric that will include these resource attributes as labels. Then you have to do a kind of awkward joins if you want to use those labels with your metric, or you can add those labels, those resource attributes as labels on your metric, but then you might overload the series with too many labels. So I think the good middle ground is here you can use the transformation processor, which makes it possible for you to maybe copy some of the resource attributes to the metric labels, but maybe drop the rest that you don't need, so you can filter out only the ones that are important to you. Unit and type suffixes, this is another thing where in Prometheus we're commonly used for unit and types to be part of the name, so we can have like underscore seconds, underscores total, but this is not how the OpenTelemetry data model represents units and types, or some information relating to types. So because this is actual part of the data structure for OpenTelemetry protocol, the unit and type usually would not be included in the name. So if you're exporting to Prometheus, again, maybe from some other protocol, you might have to look out to make sure that the unit and types are added as suffixes to your metric names. Let's look at the operator. So OpenTelemetry project also includes an operator that's currently being developed and used. It manages auto-instrumentation, but most importantly for us now, it allows you to manage collector instances. It comes with a set of CRDs where you can define your collector instance in a CRD. Many different features. It supports rolling updates. There are multiple deployment modes. You can inject the collector as a sidecar. It supports horizontal auto-scaling. It's also installable via Helm charts. There's a whole Helm chart repository for this. And most importantly, for our uses, there is also this special component called target allocator that specifically works with Prometheus receiver. And it evenly distributes Prometheus targets among a pool of collectors. And then for each collector is then responsible for scraping subset of the targets that the target allocator allocates to that collector. This is then done via the HTTP service discovery. And even more interestingly, it can also discover and use Prometheus operator custom resources. So if you have your service monitors, pod monitors defined, the target allocator is also capable of pulling these in and including them as the targets for scraping. For all of this, just a little teaser, I'll also be part of this tutorial session at the KubeCon NA, so if anyone who is there, you can check it out. It will go into much more details. So what to look out for? I mentioned now a bit about scalability and sharding, so this is possible with the operator and target allocator. You could shard and horizontally auto-scale the collector. We didn't mention rules or alerting at all. So if you're using the whole Prometheus server and not just Prometheus agent, this again, it's outside of the scope of collector because it doesn't have any querying or storage capabilities. So it might depend on your backend solution. Again, if you have some alerting or rule capabilities in your SaaS offering, or if you're using one of the distributed versions of Prometheus, you need to make that shift. Data model differences, I already talked about what to look out for. Stability of components, this is also an interesting one because the stability is declared as beta, which you can read the definition here from the collector repository. So it sounds like it's usable, but maybe that reference to non-critical production workloads might make some people uneasy. But in general, it seems to be usable. So what is the conclusion? As we've seen, it's not super complicated if you want to go from Prometheus and use Prometheus receiver and Prometheus exporter. So if you make just the direct line between Prometheus receiver and exporter, you should end up with a similar experience as you would with, for example, Prometheus agent. As we mentioned, converting between protocols requires some more attention because there are some differences in data models that can also affect how your metrics will end up in your on the other hand, on the other side of the pipeline. Automation and migration also possible. You can look into the OpenTelemetry operator. So I think in general, the collector is also usable for receiving and exporting Prometheus metrics. I think it's always good to look out for issues. There are here and there. I think there are still some bugs that needs to be ironed out. But on general level, I would say you can use this. So that is all from me. Thank you.
Hey, thanks a lot. That was pretty interesting. Great presentation. Does anyone have a question? Yeah, there we go.
Thank you for the presentation. I'm actually curious about when it comes to the usage in a cloud, for example, that there are several thousands of services that they are using some kind of client that ships data. When it comes to comparison with Prometheus, also for the client, but also for the collector, do you have any data for the comparison between those two when it comes into resources, like CPU, RAM usage, and if there is any other metric that you're aware about? Thank you.
Yeah, I was expecting this question, and yeah, I don't have an answer for that, honestly. So I think there are a couple of things that make it hard for me to like compare. Maybe first, there was a lightning talk by one of my ex-colleagues yesterday, by Daniel, who was doing something like this. If I remember, he was comparing Prometheus agent with doing the same with the collector, and I think the outcome of his experiment was that agent is obviously more, the Prometheus agent is more performant, so it loses less CPU and memory, but I think then you have to look at obviously how the Prometheus agent is specialized and how much work was put into it, and on the other hand, how the collector is much bigger, I would say, or much heavier piece of code with depending on also what kind of distribution of the collector you use and how many components you have there, and also what all of the things that you're doing with the collector, and not to mention how you scale the collector or how you use some of the tools that the collector makes it possible for you to, for example, limit the memory that the collector uses. So I don't have a good answer for that, and I guess there's still, if there are more data points or more comparisons available, I think that would be helpful if it's possible to make them on some reasonable level.
Okay, so we have one last question, and then we move on to the next talk.
So the question is focused on the collector operator. The Prometheus operator is starting to work towards the outscaling features, and ignoring that the Prometheus server cannot just simply scale down because we would lose data. Another challenge is reallocating the targets. So during the reconfiguration of the shards, do you see in the collector a strategy to not, the exact moment that we are reallocating targets, do we duplicate and scrapes a target twice by accident? Is there any logic to prevent that?
I think if that relates to it, I think that I'm not sure. I'm not aware of such issue.
Sorry. And thanks anyway.
Okay, thank you. So then, thanks again for the presentation.
Thank you.
And now, next up is the end-to-end testing of application observability in Kubernetes, I guess.
Your name is João?
Cool. So you're already set up. So let's dive right into the testing Kubernetes apps observability end-to-end. Welcome, João from Red Hat.
So, hello everyone, my name is João. I'm a software engineer at Red Hat, and I'm thrilled to be here today to talk about a topic that is crucial to the health and performance of Kubernetes applications, but even applications in general, testing observability features. As developers and DevOps engineers, we understand the importance of monitoring our applications, right? That's why we are here, diagnosing issues and ensuring our alerts are accurate and timely. So today we'll delve into how we can achieve this using Prometheus, alert managers, and various testing frameworks and libraries. First, a little bit about my work. I'm contributing to the KubeVirt open source project. For those of you that don't know, KubeVirt proposes to allow us to run virtual machines as native workloads on Kubernetes clusters. Nowadays, I'm participating in KubeVirt with most focus on observability features in the project. So, moving forward, I'll present you the agenda. I'll start with how to set up a test environment and what it should look like. Then we'll start to talk a little bit about how to test metrics. From there, how to ensure that our alerts are actionable, relevant, and real. Then how to test these same alerts, and I'll show you a little bit of a demo/showcase. So, starting up on how to set up the test environment. First, let's try to understand what these test environments should look like. Probably most of you already use tools like this, right? A while ago, somebody asked how many of you were using Kubernetes, and most of you were. So these tools are probably very familiar. But the idea here is that we want to simulate conditions that approach our production environments, but in a controlled space, right? Without the risk of causing disruptions to actual users or developers that might be using a dev or a staging environment. That's because in our tests, we want to mess with everything, right? We want to delete resources, create different resources, remove permissions, cause network issues. And this is where the concept of a disposable cluster comes into play. These disposable clusters is basically a temporary Kubernetes cluster that you can create just for the purpose of the testing. The beauty of this approach is that you can spin a cluster, you run the test, and you just tear it down once you're done. Most of the times they are really cheap and quick to set up. And we can ensure that we always start the tests with a clean slate. We don't have to worry about any leftover artifacts that we might create from previous tests or weird permission changes that might affect our results. So spinning up these clusters can be achieved with tools like Kind, which means Kubernetes in Docker, Minikube, MicroKatos, or any other that you might know. On KubeVirt, we actually do it a little bit different. We have this really cool tool already, and I personally use it every day because it really simplifies our job. It already comes with everything you might need to test everything, and it creates a cluster. It, for example, has the flag that we just set to true to deploy everything monitoring related. So it takes a lot of responsibility of thinking about it. But later on the CI and automated tests, we are using full provisioned clusters. But I mean, that's kind of a bonus for more mature projects, right? We are in a stage where we want to be sure that the testing conditions replicate the conditions that we'll face on real clusters. We have a lot of users. Many companies are vendoring this project. So we try to make sure everything is working fine. But as I said, this is a step that we can implement a bit later when the projects are more mature. So let's advance to how to test metrics. Metrics are the base of observability, right? They give us the insights on the behavior of the applications and help us diagnose issues. So we'll try to explore a little bit on how to write the tests for these metrics. Are unit tests enough? Well, I guess this is a dumb question, right? Of course, unit tests are not enough. But in the ideal world, everything will be fully tested. But all of us know that that is not possible. Time is limited. Personal resources are limited. So we can't have everything. So unit tests, yes, are kind of enough, at least in the beginning. In my opinion, I guess the most important part is to first add end-to-end tests for alerts, and then later we can add those same kind of tests for metrics. Usually, most of the alerts already use many of the metrics that we create, so if we make sure that the alerts are working correctly, we'll have some degree of confidence that the metrics too are working correctly, right? So in these unit tests, what points should we validate? I always suggest to start simple, and most of the times the simpler things are the ones that in the future end up by saving us the most time. When talking about metrics, it's usually very important to validate that they follow the right naming conventions. If possible, for example, what we use is that we try for the metrics to be prefixed with the component name. We'll see later on an example that I will give that for customers and products with many components, this will help save a lot of time in the future. And we want to add unit tests for functions that might update metrics and validate that after they are executed, the metric is updated to the correct value. Then again, we'll see later on the demo. So let's move on how to ensure that the alerts are actionable, relevant, and real. And I guess this is the main concern about this topic and this presentation, is that we don't want to be flooded by false alarms or even miss critical alerts, right? So we'll try to discuss on how to ensure that the alerts are correctly configured and that they react to the appropriate triggering conditions. I brought this code. This is probably one of the most known codes in the area, and probably many of you already saw it, that every time the pager goes off, I should be able to react with a sense of urgency, and I can only react with a sense of urgency a few times a day before I become fatigued. Actually, yesterday we had a talk by Monica that mentioned this exact same issue. So most companies are facing it, and this just helps show that the problem is real, and we need to take action to improve our solutions. And because we need to know that this kind of alerts might actually wake people in the middle of the night, and this is even more important when we produce software for external clients, because we don't know their conditions, and we don't know, for example, how many on-duty people they will have and where those people are located. I've worked in a small company before, and we were just 2 people managing the infrastructure, but we had users like all around the world. So if we had a critical alert, one of us had to wake up in the middle of the night. So it better be a real alert, right? And so for alerts, the few bullet points that I have here that they usually should have configured is that they should have an owner, like a contact person that is able to quickly figure out the problem that created the alert, or the process, or the metric it refers to. As in metrics, we should be able to quickly identify the component to which the alert refers to. For example, if you have a Kubernetes operator that is managing resources on IBM Cloud, and we might have the alert triggering that IBM Cloud is not available, if we can quickly identify what the component is responsible for the alert, we can more easily go there and navigate the logs and understand the problem quicker. Also have a summary and a description, and I think these two are pretty straightforward, right? And we should have a severity and a handbook URL, which we'll look in more detail in the next 2 slides. So for the alert severity, we should use at least a small set of defined severities. The ones usually suggested are critical, warning, and info. And this is super useful to distinguish which actions we should perform to sort priorities on the upcoming alerts. When we get a critical alert, usually we will page people. If we get a warning alert, maybe let's just create a ticket to be looked later on in the same day or in the next day. And if you have an info alert, that usually don't perform any immediate action, and just create a ticket to be looked at when we have the time. In terms of the alert handbooks, in my opinion, this is very, very important, because they serve as a comprehensive guide for owners and operators. And they should provide step-by-step instructions on how to handle a specific problem. If we don't provide these handbooks, usually owners and operators will need to go through documentations or their own personal notes to debug and fix issues.
It's something with the cables somewhere, but we will get it fixed. So we need to just wait 1 or 2 minutes, and then we can continue with the talk. No, don't have another quiz. I don't know. Maybe you can do some hands up, like who actually used OpenTelemetry yet? Only very few people. So, and for comparison, Prometheus, I guess everyone, right? Okay, so that's the state of the adoption of OpenTelemetry at PromCon. So, not know if it's representative. Yeah. What? Who wants to use OpenTelemetry? Yeah, that's a good question. So, who wants to use OpenTelemetry in the let's say OpenTelemetry metrics. Let's make it specific. OpenTelemetry metrics in the future. Anyone? Yeah, that's more. It's actually it's different people than who use it today. That's funny. Cool. By the way, but something I could tell you that's actually probably more interesting. Tomorrow, on Saturday, we have something called the Dev Summit. So if you don't know how the Prometheus organization works, so it's basically we have the Prometheus team members, and once per month we have a Dev Summit where we all meet, go through an agenda, and take decisions on whatever, whether we want to have an OpenTelemetry endpoint or not, and things like that. And once per year, it's always the day after PromCon. We don't do it as a remote event, we do it in person. And this will happen tomorrow, I think, at a Google office, and it's not exclusive for Prometheus team members. So everyone who actually likes to join a Dev Summit or whatever, has some opinion on something, or just wants to listen in or say whatever, like everyone's invited. So if you want to join a Dev Summit, yeah, here's the organizer. So you can just drop by the Google office tomorrow. I think it starts at 9 or there are 2 Google offices, right? Which one is it? Or is there only one in Berlin? I don't know. Okay, the main Google office in Berlin. And yeah, so definitely drop by, join the discussion. It's always good to have a couple of users there, hear your opinions. It's a pretty open event. And if you cannot make it tomorrow, the virtual Dev Summits, like the regular ones outside of PromCon, They are also open events. You can just join, on Google Meet, listen in, be part of the discussion, etc. Cool. So it's looking black screen still. Let's see if we can get this fixed. By the way, your time is running off. I'm sorry. No, just kidding. We have a break after this talk, so it doesn't really matter.
Oh, no one is gonna eat thanks to me. Yeah, but maybe is it possible to do the break now, and then we can keep
that
this?
Would be an option, yeah. If we cannot get it fixed immediately, maybe
it will give us half an hour or something to fix it, right?
Let's see. So is it worthwhile waiting? No, we tried. It's not the laptop, it's the cables. So hey, we see the picture again. We can actually continue with the talk. Thanks for fixing. You're awesome.
Yeah. So picking up where you left off, I was discussing about the importance of alert runbooks, right? And I was saying that they are very important for owners and operators when they want to get down and try to fix an error that is causing an alert, right? And I was saying that usually when you don't have these kinds of guides and step-by-step tutorials, usually operators will go through documentation or their own personal notes to try to debug and try to fix the issue based on previous experiences or some weird forums on the internet. And usually this ends up wasting valuable time, right? And when we are talking about businesses, losing time almost always equals losing a lot of money. So, and this not to mention that sometimes they even might be forced to rely on just memory, on improvisation, and when that happens, that even might lead to even more errors and mistakes made by them, which might mean even more delays. So, let's move on testing the alerts. As for metrics, the idea is more or less the same, trying to start with simple steps, and because sometimes, again, those steps might save us from a lot of headaches in the future, and we should validate then that each alert includes all the mandatory fields, that each handbook URL link is a valid link and actually points to an existing document, sometimes happened at 404s, and that each alert includes a reference to the origin instance or to the origin pod, and that the alert is obviously triggered when the expected conditions are met. So let's go down to the demo. I need to increase. So basically, starting with metrics, we just have some logic to register our metrics and then to later be able to list all the metrics that our application register. For these purpose examples, I'm developing a Kubernetes operator called test operator, and for now, I just want a metric about the number of reconcile loops that it's a counter. And I go to my test controller that has a lot of logic here, but basically every time the reconcile loop is called, wherever some actions perform, if you are not using operators, we just increment the reconcile total metric, right? So let's look at our metrics tests, and the idea here is that we want to validate, as I said earlier in the presentation, that we'll try to link the metric to validate every field is present, and in our use case that we want the metric to start with a prefix test operator, so we can later be quicker to understand where the issue comes from. And I have this link here because on KubeVirt what happened is that in the beginning there was not much of observability team and not much of concerns about monitoring, and so developers just add metrics as they went and as they thought were needed. And what happened is that when later we tried to enforce the linting, most of these errors actually are already validated by PromLint, but none was being used, so we get this extensive list of metrics that do not match the conventions, and now it's very hard to deprecate them. We need to start about deprecating policy, how many releases to keep them, how to warn users and vendors that these metrics are no longer available. So, as I said, when you start even that in the most simple of ways testing early on, in the future it will save you a lot of headaches. And so moving to the test itself about the update of the metric, we just get the initial value of the reconcile count metric, then we create a new test reconciler, we call the reconcile function, and when we get the value of the metric again, we expect that the value of the metric is equal to the initial value plus 1. It's a very simple, right? The logic is not complicated either. We can test here, for example, when the errors might happen, when the resources are updated. Like every metric more or less can be tested in a very simple manner. So, moving forward to rules, let's start, for example, with recording rules. So here we have a set of recording rules related to the operators, and these are rules that probably very simple and most of people might have. The number of pods of the test operator that are running in the cluster and the number of ready pods. This will later be used for operator alerts. As you can see, I have here the test operator down alert. It's using the recording rule. I have all the fields that I mentioned that might be useful: summary, description, the handbook URL, a severity, and yeah. So, and I'm writing the tests for the alerts. Once again, very simple stuff. Let's list the alerts and validate that the alerts are correct. Actually, since we are working a lot with Kubernetes operators, we actually contributed to Operator SDK with a set of observability best practices, and every test that is here, it's recommended on those very best practices. For example, the alert must have a name and it must be in Pascal case format, must have an expression, and let's validate the labels and the annotations. For labels, we just want to validate that it has a severity and it should be critical, warning, or info, and it should have a summary annotation, a description, and a handbook URL. Then again, you're probably thinking, oh, this is very basic, this is super easy to test. But then again, I showed you earlier that developers that are not very concerned about monitoring will not be concerned about these kinds of details, and it will come back to want operators first, and then later on developers themselves. So, and if it's very simple, let's implement it right away. So, now about end-to-end tests. Let's again start with metrics. So basically, before each test, let's just deploy our test operator. Actually, I have here some steps of what I did. Blah, blah, creating the operator, and I built an image, and actually I'm using int in this example, so to create a cluster, and I'm applying the Prometheus manifests to quickly deploy the Prometheus, and then some extra configuration. Here, I just deploy the test operator. On operator SDK projects, it usually means make deploy and passing the image I want to use. And I'll just create a new client. I'll also port forward for the Prometheus services, just executing the port forward command. And I'll create a new client to Prometheus and a new API, and delete any resource might be created in these very tests. So let's now see how to test that the test operator reconcile count metric is increased. We get the initial value, easy peasy. Then we apply a resource, and let's eventually wait for the metric to be updated, right? Because the resource is creating, Kubernetes is sending the request to the operator, which will then run the function. So eventually, within 1 minute, we should see that the test operator reconcile count was updated, and that its current value should be equal to the initial value plus 1. So getting the metric very easy, using Prom API, query, pass the name of the metric, time now. You can put here any more complex query you want, labels, anything, and just check for the values match whatever you are expecting. For the alert tests, first we have a quick test to validate that the handbook that we created actually exists. So here I'm actually testing again that the handbook notation exists, but then most importantly fetching the URL and checking that it actually returns a 200. I also have here the example of, maybe I don't. An example of a handbook. We have what it means to be facing this alert, fires when no test operator pod is running, the impact of the alert, indicates a failure at level of cluster, blah, 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 functionalities. So for example, on KubeVirt, for example, if Virt controller is down, virtual machines are basically running while in the cluster and nothing is controlling them. You can delete, create new ones. And the steps to diagnose the issue, how to find how many, for example, deployments you should have, which pods you currently have, and mitigation steps to fix the issue. Going back to the test, then we just add a test to make sure that the alert fires when the expected conditions are met. Basically, if we scale down the deployment to have 0 replicas, we know that eventually when we get the alert state, we should have an alert state of firing or pending. that we have like this 5-minute delay to trigger the alert, but in our end-to-end tests, if I check that the alert is in a pending state, I'm more than happy to return this as a success because I know that a few minutes from there it will be firing, so it's the same for me. Let's just check how to get the alert state. Very easy again, using Prom API, listing the alerts, and expect to find an alert where the alert name label will be the alert name that we are looking for. And that's basically it. So I just wanted to give one more useful tool. We are not actually using this yet in KubeVirt, but I've used it before, and it's Chaos Mesh. It's really simple to use and really powerful. It without almost no configuration lets you, for example, cause random issues with pods, deleting pods, being terminated, out of memory, network issues like adding a lot of latency, dropping packets. So all of these tools are really useful to simulate conditions that might happen on production clusters, right, that we don't have on local clusters. Sometimes we might have nodes that are distributed around different regions or different providers, so we want to add these conditions to the tests. And to wrap up, I just want to say that I focused a lot on it's very simple to add these steps. The tests are really simple, but then again, they will save a lot of time in the future. So now I'll be happy to answer any questions you might have.
So thank you very much. Sorry for the disruption with the cables. So nothing is really highly available. So monitoring is important, I guess. Yeah, any questions? There's one.
Thank you for the talk. It's a nice framework for testing, but I have a question. How can I test the alert which measures, for example, that at least 20% of free disk space left on the pod, something like that? Would you need to attach persistent volume in this framework?
Yeah, and in a lot of tests, for example, on KubeVirt, we are creating virtual machines, and it means to create a virtual machine, you create a virtual machine resource, which will have volumes, pods, and a lot of other necessary resources. So you can just go ahead and create any resource you want, right? The idea is that we have like this disposable cluster when we might be free to create whatever we want. So yeah.
Yeah, but I would need to fill that persistent volume with some data to reduce the free disk space and then check the alert. Right?
Yeah. And,
yeah, but it sounds complicated. I just don't understand how it works in this framework.
Yeah, one example similar that I might recall right now is that we wanted to test like for virtual machine memory. And basically what we are doing is launching a process that was connecting to the virtual machine and running a lot of no-op operations just to fill up the memory of the virtual machine. So I guess you could do the same if you create like a PVC with a very small size, right? You just create a process that connects to the PVC and just writes whatever in a text file and expect that the alert will be triggered.
Okay, thank you.
But if, like, for example, I would like to be able to confidently say that end-to-end tests on KubeVirt are fairly cool, okay? So try to check there, and you might have some hints of stuff that, and sometimes a bit of hacks that we do to simulate these erroring conditions, right? And if you check there, you surely find some cool stuff. And you can also message me, and I'll be sure to help with some more concrete examples.
Okay, thank you.
Okay, thank you for the presentation. From the example that I saw you had on your slides, you are setting up the cluster.
Before
each test.
In the code?
Or in the code, yeah. So this, I mean, my understanding is that it's kind of a costly operation. Like, how fast can you run this end-to-end tests? Like, do you have also parallelization so that you can run more of, I mean, multiple tests at the same time in different clusters?
So yeah, and this is just a small demo. So deploying the operator every time is not costly, and you'll actually will check that. Check if operator is already deployed, so it doesn't do anything because it's already deployed. But yeah, what was the second part of the question? Yeah, and that's why I started with unit tests, right? And I find that a lot of times end-to-end tests for alerts and monitoring stuff actually take longer than the rest of end-to-end tests for other parts of the code that are not related to monitoring, because we might have a lot of waiting time because of Prometheus scrapping and so on. So one of the few things we do is like already the pending state is a very nice addition. And for example, on KubeVirt, I submitted a PR for in the tests to reduce the waiting times. For example, sometimes the alert has a metric that checks the last 5 minutes, so or 1 hour, some stuff like that, right? Because, for example, a warning for iMemory might be in the last hour. So I just go to the Prometheus rules and replace everything with 1 minute. So we are much quicker to trigger the tests. And when I submitted that PR, I reduced the time it takes to run these tests from 2 hours to 40 minutes. So that's the kind of long values we are talking about. Yeah.
Okay, so thanks again.
Yeah. Thank you.
So break is now 20 minutes instead of half an hour. We meet again 3:15. And after that, the 2 last talks and our wonderful lightning talk session.
I can also, I guess,
Okay. So, one last time. After the break, we are continuing. How's everybody feeling? Okay, good. There's still some energy left. I'm like on the edge now. So, one of the second last full-length talks about Metrics Explorer. I'm super pleased both of you could make it all the way from the US. So, yeah, I'm thrilled and I'm looking forward. Take it away.
Thank you, Matthias. Hello, we are here to present the Metrics Explorer, a tool used to learn about Prometheus. I'm Brendan O'Handley, a software engineer at Grafana, and I work on the metric data sources. So this includes the Prometheus data source in Grafana. And Catherine?
Hey everyone, I'm Catherine. I'm a product designer at Grafana, also working with Brendan on the team that maintains metrics-based data sources. So today we'll be talking about something a little bit different, a user-focused case study on building the Metrics Explorer.
Cool, thank you. We're very happy to be here, and we'll talk about the background of the Metrics Explorer, why we build it, can we give users more power to explore, the learnings from user testing, and our next steps. So a little bit about the background. In 2022, Grafana set a goal to improve the getting started experience for new users. We know historically Grafana has catered towards power users and early adopters, but we also knew that the product could be challenging for new users, especially Prometheus beginners. So we wanted to make getting started in Prometheus easier and to expand to more audiences. So we created the first cross-functional planning to have a collaboration between UX, product, and engineering. And with the spirit of collaboration guiding us, we looked at our users' workflow, identified areas of biggest impact, and Catherine and I that work on data sources, we work on parts of Grafana that involve configuring data sources and querying data. So this was a great opportunity to look into. And this research guided why we built what we built. So the research plan, it was put into place to understand how users interacted with the Prometheus data source. And we wanted to focus on Prometheus in Grafana because it's our most widely used data source. And I want to say, as an engineer, this was different than my normal work, but it was also very exciting and very eye-opening for me. What I got to see clearly the gaps that new Prometheus users have in their knowledge, and it also allowed me to come up with ideas on how to solve for their pain points. So this research included workshopping, user journey mapping, persona creation, and interviewing users. And we started with a workshop with Grafana employees. We brought together software engineers, we brought together UX researchers and product to provide feedback on the whole getting started process. Within this workshop, we came up with the ideas and we created some solutions for some of the pain points. And please don't try to read any of the sticky notes, or just make sure everybody got to participate and contributed. And from this, we started to create a user journey, and we defined the user journey in Grafana as a user having and moving through the Grafana UI with a purpose involved. And so this purpose or goal we had was running their first query. And we mapped out this user journey based on the workshop discussions, our research, and our knowledge of the product. So we wanted to use this workflow around discussion points within our user interviews. We wanted to ask where people were getting stuck, and what were the pain points in this journey. And who are the users or personas that we explored? Well, we researched and we found there is a super user, which is usually an admin or a senior member of an organization, which will configure Prometheus. They are also responsible for creating and assigning different access permissions. There is also a querying guru who may be creating dashboards or writing raw PromQL, and they are writing queries, and this is something they're familiar with. And there is the user for which we wanted to focus on, who we wanted to solve for. And this is the observer or the beginner. This is a person who may be new to the observability space. They may require some guidance or mentorship. And another interesting point is there's another user type under this persona who's not an engineer. And these users may not write queries, but instead use the dashboards to view specific metrics. They may navigate around, or they may set thresholds. With these personas in mind, we began to conduct user interviews, and we mainly focused on new users since this is who we wanted to solve for. And we asked these users how they used Prometheus in Grafana, and we asked them to show us as they navigated through the UI. So what were some of the things that we saw? What did we hear? Well, the Prometheus query editor in Grafana is very powerful, and it has some amazing features, but we did want to focus in on some of the pain points and opportunities to help people out. And we found that users found it challenging to navigate through the metric select list with tens of thousands of metrics. It was sometimes challenging getting started with a query. They didn't know what metrics existed or what metric to choose when writing a query. So we had a lot of findings from our research, we had a lot of outcomes, but we had to focus in on one of these to start working, and we chose to work on improving the metrics browsing experience. And it was at this time the feature lifecycle was moving along nicely. I coded out a prototype and began working with some of the designers to start iterating on this. With this collaboration, it's a lot of fun. We named the early project the Metric Encyclopedia as like a reference, which you could page through and look through all of that information. The designers and I, we entered this into a hackathon, and we had a lot of fun. But this wasn't all. The design got sharper and clearer, and in the spring, Catherine joined our squad full-time, and we continued to iterate on the design. We continued to do user testing, and as we rolled this feature out in the feature toggle process within Grafana, we started to get more feedback from actual users, and from this, we continued designing. We renamed the feature the Metrics Explorer. We reorganized and refined the search settings. We used the space better, and it was looking very good. But we still continued to do user testing to make sure that we were providing a solution for our new users. So here is one example of the user testing.
Okay, I mean, immediately, I guess what I'm seeing is there's 151 pages paginated. That's good information. Before, I was dragged the drop down to see how many things existed. Now, I just press this button and I'm like, whoa. I can also, I guess, probably do what I did before, which was search for latency. Oh, I mean, I'm already getting like, yeah, there's that many latencies, there's that many durations. These are all just good, simple. I mean, I don't even have a task in mind, but if I was just looking around what metrics exist, yeah, this would be a huge help.
Cool. So what are some of the features? What's some of the code that we've implemented in this? Well, you can search for metrics by name and description. And when this can include tens of thousands of metrics, we chose to use the ufuzzy.js library to search through that. We also added a filter for Prometheus types. Metrics are displayed in a paginated list with configurable number of results. We show the metric name, type, and help description in the display, and we have an additional setting for a regex matching search. So a little deeper. Because we're dealing with tens of thousands of metrics, we chose to use the ufuzzy library, which is capable of searching through or call a haystack of hundreds of thousands of strings or phrases, and it can sort results by relevance. And so when we were searching through many, many names, and then the additional search by help description, this was very fast, very performant. In addition to this, the Prometheus types. We know that not all metrics have metadata that includes the type, and we know that some types will create other types, like histograms and counters, and we wanted to bring this to people's awareness, so we added the filter by type, and we are interested in the Prometheus work around metadata for this, as a side note. To continue on with some of the code, as we did interviews, we also did interviews with super users, with power users. And so one of the requests for that was a regex matching. And we know that Prometheus endpoints support this. So we included this within the metrics explorer. So what does all of this look like? Here is our demo.
And we can see our metrics listed by pages with type and description. The Metrics Explorer can search for metrics with a fuzzy search. So this means that we can spell our metrics closely, and if we spell them incorrectly, we can still get relevant results. Search results are also ordered based on relevance to the input. So if we search for the metric up, the first metric that we get is the metric up. Results are shown in a paginated table list here. We can see the pages, we can see the total number of metrics, and we have results per page that a user can change. A user can also filter by Prometheus type. We have the counter, gauge, histogram, summary, unknown, and no type, where the metadata is undefined. When we have no type. The Metrics Explorer also has additional settings which can broaden the search, filter results by metadata, change the UI, and change the underlying mechanism for searching to search with regex using the backend. First, a user can include description in the search. So if we look for data, we can find data in the metric name, and we can also find data in the metadata description here. Next, a user can include results with no metadata or exclude results so that all of the metrics listed have metadata. We can disable text wrap, and we can enable a regex search using this setting.
Cool. So that was our demo, and I will pass it on to Catherine. Thank you.
Thanks, Brendan. Now let's talk about what's next with the Metrics Explorer. Now, the Metrics Explorer solved the initial need of having users understand their metrics, but there was an idea. Why don't we add labels and values to this feature as well? We can show all of this metrics metadata, but also allow users to be able to search and select their labels and values for their query. Now, this functionality already exists in Grafana in a feature called the metrics browser. So if someone's writing a query, they're able to kind of see all of the metrics, their labels and values, and add to it. So this is kind of what that looks like. On the left, there's a huge list of metrics here, and this is kind of just me scrolling through it, and this is kind of what it looks like when going through that. And then you have the labels and values on the right. However, we've been hearing about performance issues in the metrics browser. We've been calling the series endpoint, which calls the metrics, values, and labels at once, but for customers, that could mean a call for hundreds and millions of metrics, hundreds and thousands of values, and then all of those associated labels with those values. So you can imagine all of the performance issues that this can lead to. So what if we fix this as well? So we can call the metrics, labels, and values using different endpoints, and then we can match them with a series selector. And then that means the labels would only show if the metrics were selected, or the values would only show when the labels were selected, and this would be much more performant. So we wanted to kind of tackle these two birds with one stone, kind of adding those labels and values, and then also kind of fixing these performance issues as well. However, calling metrics, labels, and values separately meant a few different things. And the biggest question we had was an important interaction question, which was, how do users currently use the metrics browser to kind of add to their query. Do they look metrics first, or do they look labels first? So right now, here, users can interact with this feature at any step they want. However, if we wanted to kind of have separate API calls for the metrics, labels, and values, we had to have a more opinionated kind of stepper flow to guide users through this. So we gathered qualitative and quantitative data to see how people searched. I learned that users actually searched by labels first and searched by metrics first equally. People would kind of search by labels when they weren't sure what the metric name was, but they knew that it was like in this cluster or in this job. And if people had some sort of idea of what the metric was, they would search by that first. So while there was kind of a parent-child relationship between the metrics, labels, and values, the way it's searched for isn't. And this I will come back to a bit later. So based off of this, I redesigned the Metrics Explorer with two different views. One where users can view by metrics first, and one where users can view by labels first. So in this metrics first view, you have a list of all of the metrics here. If you toggle into one, you see a list of the labels and then the associated values with it. And then in the view by labels first, it's kind of like a stepper kind of flow where basically there's a list of all of the labels on the left. If you toggle into one, you see values, and then if you select the values, then you see the metrics. Following that, I wanted to be able to perform some user testing to kind of gather some feedback around this, understand friction areas, points of confusion, as well as getting some design feedback. So basically with user testing, I had people basically perform a series of tasks and go through a design prototype where they would essentially try to select specific metrics, labels, and values. And there was quite a bit of confusion and difficulty when it comes to the navigation. So after observing 5 different users go through a prototype, what I learned was that users really struggle with the scrolling. So you can imagine, as I said before, there was like potentially millions of metrics or like hundreds and thousands of labels. And then within this view by metrics, users would have to do a lot of scrolling to get to what they want if they weren't sure what to search. So there's a lot of scrolling that could potentially happen. In the view by labels, you can only see 5 metrics at a time as well. So that for them was also challenging if they can imagine how many metrics they have. And a lot of this is also due to the fact that they were already kind of using the metrics browser where it's very dense. You can see a lot on the screen. Another thing that was confusing for users was that they found that the 2 different views, the nested tree and the steppers, to be confusing. So as you remember, like you have the metrics where it's like the nested tree, and then you have the labels, which is like that stepper. But for users, when they had to kind of navigate between the 2, the change in UI and then the change in interaction patterns was very confusing for them, and they weren't sure why there was such a big difference. And some users also still didn't understand the relationship between metrics, labels, and values. So they mentioned that, hey, I'm not sure what I'll see in this dropdown when I'm kind of looking at this list of metrics. And when they clicked into it, they still weren't sure what these things were. So thinking about these kind of challenges that users had, we were kind of wondering, like, why were there kind of these problems? So thinking about this, one of the things we realized was that we were putting in so much content into the initial Metrics Explorer modal. So originally, this was designed to help people learn more about their metrics. So there was a lot of white space, there were tables, but we were putting in all of this additional functionality and really clashed with the original intent and the way the UI design is to really help people learn more about their metrics. So we were thinking maybe that should just be its sole purpose because everything else was just adding too much functionality into this pop-up. Also, the nested tree structure allowed for teaching opportunities. However, for the users, the main purpose was to really build a query as quickly as they can by finding the metrics, labels, and values as quickly as they could. So for them, like going through that nested tree structure was just friction points and getting to things quicker. So what did that mean? So it kind of means going back to the drawing board now. We're looking at ways to redesign the metrics browser instead, and I'm exploring some of those new designs. So maybe users would want to kind of view metrics separately from selecting labels and values. So here they could basically potentially open up a drawer by clicking on a button, and then they could see all of the metrics metadata in one part. You can kind of view it more slowly and have that completely separate from the metrics browser. Or maybe they just want to see the metrics metadata in line with all of the metrics within the metrics browser instead. So just having everything within the same view. To inform our decision, we're surveying our Metrics Explorer and Metrics Browser users to fully understand how valuable they're finding each feature and how often they use it. We're also crowdsourcing their opinions to determine if there's one option that's clearly winning based off of how they're browsing for metrics and using that to inform our next steps as well. So in the end, there was a lot of collaboration across engineering UX, and we built out a great solution that solved for user needs. But now we're really thinking about what's best for Grafana, product and UX-wise. We're iterating, going back to the drawing board, and taking the time to think about, hey, we had this research, we had a good idea, and now reimagining it with the rest of the product. So this, again, is the before. This could potentially be the after, but we are still exploring. And that's it. Thank you, everyone. And does anyone have questions?
Awesome. I'm sure we have questions. Yes, all right. Any questions on this side? I can already start walking to you.
Hello, thank you for the talk. So I assume that this problem can be unsolvable if someone has like 10 million, 100 million of active time series. You just can't recognize them well. But have you considered following from the smaller to the bigger, like identifying those labels which have the lowest cardinality? So for example, even for 10 million active time series, someone can have metrics for prod and metrics for dev and metrics for staging, and show these lowest cardinality labels first, and that will go like a filter from the lowest cardinality to the higher cardinality. So user can pick, I want to see metrics for prod, then for job, I don't know, my cube job or something like that, and only after that you will show them the list of the metrics related to that.
So you're mentioning showing just like basically the cardinality within the labels themselves and having users be able to select from that?
Yes, like to make Grafana to explore the cardinality first and going from the smaller to the bigger.
Yeah, so right now it's not listed in that view, but that's an interesting idea that we'll explore.
Thanks.
Perfect.
Yeah, so I was always wondering while using this browser, can you have some feature like the most used globally metrics will be highlighted somehow with star, with something like that? And even if all the dashboards are using, like for example, one metric for monitor for memory, I think it will be useful to be visible somehow.
Do you mind? No. So currently, we do have access to how many metrics are used within query history to possibly find that, but we have not considered that yet. But it is a good thought. Thank you for bringing that up.
Yeah, we've definitely heard this feedback though from other users as well, seeing like even like, for example, like a query history or just the metrics history. So that's definitely something that we're considering within the roadmap.
Did you find that some label names might be context sensitive for an organization? Like they are maybe used in a particular way for a particular group of users, or was there no pattern there?
So we found that for users, like it really depended on kind of like where the labels were coming from to some extent, but that wasn't something that we were really testing within our prototypes, mostly because we were kind of just seeing if like users were kind of like exploring by metrics first or users were exploring by labels first. But we didn't get any insight into whether or not like where those labels impacted like how they searched for them.
And later on, for additional research, we were interviewing expert users with Prometheus, and they did request things like that. The solutions we came up for that were that having the admin configure those labels and some sort of library that other people could reference. But we've not looked into actually creating that solution yet.
I have like a question. So first thing is like really cool to see the filter by type and stuff. But I feel like one of the like challenge that usually happens, maybe it's the next step from the Explorer, is like looking correlation between two different metrics that might have similar labels. That will be something like usually challenging as well, right? We have like two different metrics that actually can be connected by group by here and there. But it's kind of hard to know like how can I actually utilize this metric to get better visibility or no. Is that something that you were also like looking into exploring more on the Explorer, or maybe it's like different tools to help get that kind of like visibility on utilizing the metrics better?
So correlations between metrics by similar labels?
Yep, so the one labels have the, let's say the instance type, it can be in some metrics, and the other metric also have instance type, for instance, and it would be really cool, right, if we can actually just, this label's actually connect to this one as well. You can actually get the same thing, and you build PromQL out of those.
That would be very interesting. We did not explore that. After you.
Oh, I said we would love to learn a bit more about just like your use case. Maybe we can chat after.
But the way the bitmaps work underneath, it should be pretty performant. Random side note.
In Prometheus world, the most metrics which are created by Prometheus have two labels, mandatory labels. It's job and instance. And have you considered using these labels, highlighting these labels in Metric Explorer, or using it putting it in front of during the Metric Explorer? For instance, you can just put job label in front of all the labels, and then a user can type the job he wants to search, and then after that he can explore other metrics which belong to this particular job.
This is very interesting. That it is to have some things known, like you mentioned, that their job and instance are used quite regularly. I think that we could research more into this and find those consistent labels used across organizations. And it kind of reminds me about what was mentioned earlier about having some labels that would be appropriate for many, many customers, and then others that are specific to some systems. Interesting. Thank you.
Make it quick.
One last.
Hi. Do you see that there's a need for this kind of Explorer if you could have a ChatGPT-based alternative? I mean, would users prefer that, or do you still see a need for this approach?
This is a very interesting question. So our same team is doing the implementation for with LLMs and with vector DBs and query history. And we have a project that we're working on for metric select based on using LLMs. And so while that project is still in development, eventually we will do some user testing to compare these, I imagine. Yeah. See the efficacy of them and how they help users. And so there's still research to be done. Like everything that comes from the Metrics Explorer comes directly from Prometheus, but then for the AI supported or the LLMs, there is the additional step. And so we're still researching and testing that, but we see a lot of promise in it.
Yeah, so for the LLM feature, we're focusing on the problem of users, like especially beginner users struggling with PromQL. So that's the first thing we're looking to tackle with AI. But adding in kind of like the ability for users to be able to select a metric could be a potential next step. But we have this right now, and then we also want to really focus on that like querying experience, just like with pure PromQL first with the LLMs.
All right, thank you so much.
Awesome. Well done. Yay. Thank you, Matthias. Oh, this is so sweet.
Awesome.
Cool.
Do you have HDMI. Yes, on this side. While we're configuring the display not to be mirrored, we asked yesterday whose first time it was at PromCon. Whose first time is it in Berlin? Wow, okay, that's pretty amazing as well. Yeah, welcome to the city. Who's actually local? Who didn't need to travel? Who's from Berlin? That's like roughly the other half. Nice. Mm-hmm. Okay. I can give you one, yeah. Okay, then. Yeah, you can. Yeah. Okay. Yeah. Okay. So, full last length talk of PromCon 2023. You still energized? I can sense it like being a bit quieter already. We'll get there soon, and then we can have a nice weekend and get some rest. But before that, I'm super excited for the both of you to be here and to talk about your learning mistakes or learning from mistakes. Take it away.
Hi everyone. We'll be speaking on how to set right alert metrics, which we have learned through our mistakes. We are from ZenDuty, an end-to-end incident management and response orchestration platform. I'm Ankur. I have accumulated years of experience making mistakes, learning from them, and advocating for best practices for organizations setting up their DevOps, SRE, and production engineering teams. Dheeraj will.
Yeah, I am Dheeraj, and I work as a founding engineer at ZenDuty, and I majorly deal with backend stuff, and time to time I also deal with some of the infra stuff. That is why I am here, and I'm an observability thinker, and thanks to great presentation, so it got me more excited on OpenTelemetry. So let's move on to why we are here. So one of the things why we are here is to find what does the right metrics mean when you are trying to monitoring and alerting. So I know it's not that pretty straightforward. So something right is not that simple. So and especially when you are new to Prometheus, new to monitoring, it might take time. Sorry, I'm a bit nervous. So but I'll quickly catch on. Yeah, and learning from mistake. One of these mistakes, I'm nervous. So and other thing, come on, who doesn't do mistakes? So we all do mistakes, and we'll go through some of the things, some of the mistakes which we uncovered, and we'll go in deep that. And now for the most difficult part, to answer what does the right metrics mean. So and okay, sorry, and yeah, and also to answer the two important questions, that finding the right metrics which can answer your P0 incident. So yeah, we tend to configure most of the alerts which answer most of your incident, but there are a few alerts you need to configure to answer your P0 incident, and at the end of the day, it's all about the cost. So is bad monitoring costing you? So. And yeah, building a monitoring system is very hard, especially if you are new into monitoring space, and it might become pretty chaotic. So it can't be done overnight. So you have to learn from your mistake and keep iterating. And so we are emphasizing what right alerts are. So right alerts are alerts basically should have an impact. So and should be actionable. Should be concise and accurate. So yeah, that's all. And now I'll go through some of the key performance indicators which measure. Some of the key performance indicators which measure your application. So yeah, just to refresh, SLA, service level agreement. So this generally says the uptime of your website. So and SLO, service level objectives for you to meet with the teams. And the most important thing, service level indicators like latency, error rate, and system throughput, which will help you understanding your infrastructure more better. So yeah, this is another slide. Fun fact that Google Compute says their SLA is 9.95. So it means Google Compute can go down for 4 hours 20 minutes. So if you have some bad alert configured, maybe yeah, that might become pretty chaotic. And so yeah, so how SLOs are calculated? So suppose if you see an API where you have 1% of error rate, then that means your SLO will be 2 nines. So yeah, this is how you monitor your SLOs, and you can see some of the monitoring stuff. And this is another slide where you can see over the 30 minutes what was the availability of your pod and budget. Yeah, error budget remaining, that is almost 6 hours 48 minutes. And yeah, I hope you are familiar with this. So we as a developers tend to see this a lot on our daily to daily basis. And yeah, oops, I think we just got alerted. Maybe I'll hand over to Ankur.
So thank you, Dheeraj. So moving on, we'll be going through some alert configuration, which scenarios which we collected through our own experience and also by talking to a few customers. The first and foremost, which should be there, that having no alerting at all could be the biggest mistake which we can make when we are already monitoring and collecting a lot of data. We don't want our team members to keep looking at the screen, looking for those anomalies, doing 24/7. If we set the right metrics, we can actually use the time of our teammates in a productive way, because who does want to actually look at the screen and look for patterns if we have machines to do that with the computing which we have, right? We have also done some research by talking to 20 organizations of different sizes, and we have observed that they get on an average of 200 to 500 critical alerts over a month. If you're missing that many alerts in your organization, that means that many instances will come where your team member or your company will be clueless or takes more time in actually resolving those incidents, which will breach your SLAs and SLOs. The second would be, even if we start setting up alerts, if we don't actually set enough alerts, we'll still fall in the first category, where either we do have some alerts where we are getting alerts, but the scenarios where we have not set the alert, we still have to do the same thing over and over again. Third would be setting up too many alerts also. I think we have already covered, some of our friends who have covered talk about the alert fatigue. That happens because of excessive noise when we set too many alerts. It could lead to alert fatigue also. It's like creating a Slack channel where you are bombarded with all the alerts, and with all the noise, you will end up muting that. And when a critical issue will come, you will miss that. So setting those kind of alerts will have no point, and again leads you to breaching those SLAs. I'll cover a few examples on how a write alert will look like. This is one example which we have seen. So we need to keep track of our node versions at a kernel level. So this could happen. I know when people are setting up their nodes, they actually finalize what version, kernel version they're using, right? But when you set up node refresh, some people will be setting up at 2 weeks, 1 month, or maybe quarterly refresh, right? There might be cases when your kernel versions will get security patch update, which have kernel updates as well, which will lead to these kind of kernel mismatch, version mismatch. And when these things are not tested in production, this will lead to, the extreme could be a downtime. But all in all, if you have an alert set like this, you will be able to understand before it happens. Next would be high context switching. What context switching is, where your CPU switches from one process, or maybe the thread count are moving very frequently within your applications, right? So when you are early in stage of actually monitoring, you may not understand what kind of traffic you're getting and how your application is responding to these kind of requests, right? So you need to set a threshold for these alerts where you can understand what number should be there, so that which will define your configuration for your pods and replicas, like the memory which you want to put, the auto-scaling metrics you want to put, once you get to the number. In a mature system, ideally this should not be hitting that alert, although you still should set a alert for that in case of a very high traffic which you are not expecting. It's sometimes good, because if you are running an e-commerce company and you start getting a lot of traffic, a lot of orders, your company will be very happy. But again, when you don't have the alerts, and if you are not able to fulfill those orders, it will lead to loss for the company. Okay, so this is a suggestion, yeah. The other would be, this is related to our HIPAA. When we are setting up HIPAA, we have our min numbers and max numbers, right? So this is related to minimum number of pod. Although when this kind of alert will come if your minimum number of replica and your desired capacity are equal. Yeah. So you would want to keep a track of when you're hitting that minimum number. And when you set this alert at a desired capacity equal to minimum number, you will get a lot of noise. So the ideal way would be to actually keep your desired capacity slightly higher than your minimum number. But keep a track of your minimum number, replicas hitting the minimum numbers. Yeah. The next HIPAA alert will be for the maximum capacity. So if you see, we have already set an alert for our maximum HIPAA capacity, right? But there's something wrong with that. It's like if you get alerted for HIPAA reaching the maximum capacity, you're already too late for that, right? Because at that particular time, when you're already at a level where your HIPAA reached the maximum capacity, and you don't know whether the next step would be to actually get more traffic, or maybe it will be reduced, right? There's nothing you can do here. So the ideal way would be to set it in the right way. We did our research, and we have configured it as 70%, but yes, it could actually vary from 65 to 75% based on how fast your scaling happens, right? But you need to keep it under 80%. It's funny to look at it, but you need to keep a track of your Prometheus replica going lesser than the minimum value which you have set, right? The reason being, when you're getting too much traffic and your Prometheus is scraping too much data, right? If you don't have enough replicas working for, pods working for scraping that much data, your alert manager will get all the data slightly delayed, which leads to those alerts getting triggered in a late manner, where the chaos would have happened and you would have come in later on. I'll hand over to Dheeraj to cover next.
Yeah. There is another metrics called container CPU usage, which the metric simply says that your CPU usage is above a certain threshold. For our case, it's 80%. Then you will get alerted. But a few things to note down over here that based on our R&D, we configured our threshold at 80%, but it depends infra to infra. And one other important thing to look at that if you have come across this alert after a release or maybe a change in infra, maybe it's better that you roll back so that before some catastrophe happens. And same thing, high memory usage. So it's the same as CPU usage. By our R&D, we came up with a 75% memory limit, but it depends from infra to infra. So yeah, rolling back would be a better option if you have released something. So OMM kill, this is an interesting thing where generally you see OMM kills when your CPU is, when your container runs out of memory, but that's not always the case. So one interesting case would be that one of our microservices used to dump a lot of tasks, so it was written in Python, so Python and garbage collection. Yeah. So now it used to increase the space complexity way too much. So our solution was not to increase the desired memory limit over here. It's just patching the code so that you can have a better garbage collection on that particular microservice. So, and the other thing would be container restarts. So yeah, these 4 slides which I talked about are pretty much related to each other. So again, sometimes container restart may happen because there might be OMM kill, or maybe there is an internal process that killed your metrics, but there can be cases, unavoidable cases where, so if I want to give an example, suppose in case of a broker and a worker terminology, so if the broker doesn't give any AG back to the, if a worker doesn't give any AG back to the broker, maybe in under 30 minutes, so you would get a restart. So, I mean, this is the unavoidable case, but this is actually an unavoidable case. But yeah, one workaround for this particular problem can be that you separate the jobs which you know will restart, and you separate the containers for the job which doesn't restart. So you can simply silence the containers which might restart so that you don't have to worry about container restarts, but still again you can be sure that the containers which are not supposed to restart, you can get alerted for that. So other thing would be tracking your 400s. Yeah, tracking your 400s is a good thing. It's like a warning alert just to measure efficiency and performance of your application. But again, what's wrong with the configuration? Often you tend to see 4xx has a 429, and 429 are like pretty obvious if you are an ingestion engine or something. So you usually tend to see so many 429s. So if you have configured your 429s along with the 4xx, then you might see this alarm too often. So the correction would be, changing the equation where you exclude the 429s from your 4xx. And so by doing this, in our infra, we have reduced the noise by around 82%, where we can only cater to the 18% of the warning alerts due to this 4xx. And now you must be wondering that we removed 429s, but there is another tricky way where you can monitor your 429s. So one thing would be this alarm is just to monitor your 429s, but yeah. So in this case, so tracking your 429s are pretty important, and one of the cases would be that usually 429s tend to take a lot less time compared to other status codes. But if you see in this particular alert, you see that if your 429 takes more than 5 seconds, so that means there is something wrong, and so you might have to quickly look into your Redis or your DB or something else where your 429s are managed. And now 5xx are pretty bad in your service, but yeah, we are developers and we tend to make mistakes in the code. So it's a very good thing to keep track of your 500s. And now we explained a lot of metrics over here, but there are a few cases where these metrics doesn't help you a lot. So you might need application-specific metrics. So I'll hand over it to Ankur so that he can explain what are the application specific metrics, and how can you debug an issue based on that?
Yeah, thank you. So while we can set alarms on number of the error codes which we get, right, the 4x's and 5x's. But if you're already getting all the 2x's and still you could lead to your bad performance with your application, right? So for that, we need to actually keep our latency. The best way would be to actually keep an eye on your P50, P90, and P99s. Ideally, I would not be happy with the P99, which we have shown here. But in some scenarios, this will be, it has to be the case-to-case basis where you have P99 of this much as well. This is one of the examples which we have seen where you can see that our P99 was badly hit for a given 7 to 8 minutes. But if you see, it came down automatically by itself, right? Nothing was done there to actually fix it. But to do a post-mortem on it, we actually found out something pretty interesting, right? To explain that, I'll actually take you through two things, anomalies related to our application metrics. One is request backlog. It depends on, even if you're getting too many requests, your container will show your CPU is not spiked, the memory is working fine. Because at the time of running, they are handling all the requests within the given range, right? But still, there could be some requests which are still in the backlog because your worker tends to keep them in the queue. That's how the architecture is, right? The other way would be to have a busy workers, where your workers are, the busy worker could be because of your application code not being optimized to perform all the tasks at a given time frame, and that's what leads to the worker being busy. The other metric you see, a request backlog could actually backfire like that. The spike, where for a certain time frame when we actually started debugging for the above case, we found out that it was because of the backlog and not related to anything else. A busy worker would lead to this. So what we found out was that this was because of in our case, it was because of a new patch which we released to the application. It could be another reasons also, where the patch was already there, but you were not getting that many requests from the right resources, right? So, but you need to keep track of all the releases you are doing based on that. So we actually rolled back very quickly, and we were able to actually fix it in very less time. Yeah. So moving on to the next metrics, like we actually monitored number of Prometheus replica, which is important, right? The other way to keep a track of actually alert manager being connected to Prometheus. If your alert manager is not connected to Prometheus, the alert manager should alert immediately because we'll not be getting the new data if this is the case, right? And then something needs to be looked up. That why is it is because of the network layer, or maybe there is a problem with the alert manager. The next would be, we need to keep track of, because we know with Prometheus, it can sometimes go in a direction where the scraping needs to be really high, right? But to scrape the right amount of data, it could be because your settings require those much data to be scraped. But if the Prometheus does not have enough resources to scrape that much data, the way the scraping is scaling, your alert manager will still get delayed if you are not keeping a track of the scraping data which is being done. Also, it's good to actually keep track of the scraping data to keep the cost under check so that you don't get heavy bills from your cloud after a month because this alert was not set. At least you should know how much bills you'll be getting to keep an eye on that. Oh, sorry. So, but why are we emphasizing so much about the math related to just alerts, right? Because we can always put, from a company perspective, we can always put few extra people to actually work around the math or maybe look at these screens automatically, right? So we did some very basic math for a very small team, not even a very big team, and that's what we found out. So if you see this cost is based on some region of a particular cloud. So just to give you an example. So you already know our per GB cost for our NAT. And when you're setting up a NAT, you will be setting up the multiple region, multiple HA for NAT, right? So 6 NAT will be required. For a given team of, we assume the given team of 500 people, we'll have 30 engineers who will be actually using consuming the data for the Prometheus which we are getting. and this much average monitoring bandwidth consumed per person every day. So we think this is very less, but this is the cost which we'll get when we actually multiply everything. This is $59,000 roughly, right? But we did some more math if we actually set the alerting in the right way with well-configured alerting and metric monitoring, and also through Prometheus scraping, storing the relevant data, not storing everything. If it is not needed, it's always avoidable because both the things are there. When you're transferring more data, you are taking more bandwidth also to transfer the data, which leads to latency. And the other thing could be your alert manager needs to get alerted for those data as well. So for that, we have been able to identify that if you set up a right alerting, the cost save from the data transfer perspective only is 35 to 45%. In that particular case, the cost was 26,600 compared to 59,000. Great. So I hope after this we'll be generating only alerts that require attention and also keep learning from our more mistakes. We would be happy to. But how do we approach incident management here for a cleaner solution, right? This is one of the examples. One of the architecture, I think we have already seen an incident happening here an hour back where our display was not working. The production team was able to handle the incident very calmly, while the stakeholder communication was taking care and keeping the audience engaged. Yeah, we have almost done, yeah. Okay, so if you see, the error monitoring is set up with the right communication channels, with the APM, and the real stakeholder and the owner of the team. This is how incident management with everything with the response side looks like. Thank you. You can always contact us for the collaboration. We'd love to actually see what mistakes you are making. We'd love to include them or maybe talk about that and also learn from your mistakes. Thank you for listening. Yeah. There is a little Okay.
All right.
One more thing. You can actually go to this to actually, this is something which we found out. This is not written by us, where these are really cool Prometheus alerts. You can go through that. It's an extensive list also.
And we would love to discuss on community.zenduty.com if you have any queries.
All right. We have 1 minute for questions, so you can ask one question, basically, if anyone has a question. Okay, seems like we are at time anyway, so let's, one more round of applause, and then we'll start with lightning talks.
Thank you for having us. Berlin is a beautiful city. We loved it.
Perfect. Yeah. All right. So for lightning talks, we have 11 lightning talks on the paper. Unlike yesterday, you don't need to all line up because we're using handhelds. That was my mistake. I thought we need to give you headsets. So if always the next speaker could come down once I mention your name, that's enough. You don't need to wait for an hour. But the first speaker, where are you? There you are. You're Fedor? Yeah. Yeah. Okay, so. Who's the first? I'm trying to figure out the handwriting. So starts with L, Leond, Pocher or something? Ah, it's you? All right. Yeah, there's no number one. We had to make a change of plan. Sorry about that.
No problem.
The other side. Then let's change these. Okay, and then the next speaker, yeah, you are already here, yeah. Sorry? Ja, genau. You have your mic? Okay, then 5 minutes. Can we reset the counter? Okay, there you go.
Hello, so I'm here to talk about the long-term storage based on Cassandra we have built at Blimeo. So you may ask why we are building another long-term storage, which is a good question. So just to provide a bit of context, at Blimeo we provide a monitoring and observability solution as a service, so it's a cloud product. So we provide some automation based on around Cassandra, around Prometheus, around Graphite, StatD, and Nagios. We have 2 open source projects. So when we look for long-term storage, we had 3 main criteria to find a long-term storage. The first one was about the size of the storage. It's quite driving our cost. We have a lot of customers that are storing a lot of points in a lot of metrics, and the storage in the cloud is expensive. So we have a replica, we have backups, etc. So storing is quite expensive for us. We had a second criteria was speed. We wanted fast response, so our customer want dashboard to display as fast as possible for recent data, but also for past data, and we wanted a solution that is easy to operate. We are a small team, about 10 people, so we wanted something quite easy, and it's only a part of our solution. So we give a try to Cortex, Thanos, Victoria Metrics, M3DB, TimescaleDB, OpenTSDB, and we ended up building our own solution. So we were not completely convinced by the size of the data when using Cortex and Thanos. We had some issue with data, how fast the data was were getting, especially with past data, or when resampling, downsizing the data. And we were not completely, especially for Cortex, it was quite big things to install. So we made some try and build some benchmarks. So it was some years ago, about a bit more than 1 year ago, that we tried all those metrics. So it's by ingesting some old metrics, old data we had, some recording of metrics we had. So we tried to ingest them in different stores and compare at the end the consumption of CPU memory and the disk on the system. So what we build something based on Cassandra, because Cassandra is quite robust, well-known, and reliable. So if we faced an issue, we are sure we have someone who is already having the same issue. We have been reusing Prometheus PromQL engine, so we don't have to rebuild everything. We support natively pre-aggregation, so when a customer wants to downsampling in the dashboard, it's already pre-calculated, so it's faster to answer. We support single node and cluster architecture. We are exposed PromQL remote read and write endpoints, and it's ready for being multi-tenant. And we have tried the compatibility with Prometheus compliance tests, and we are about 100%. So that's cool. So in a picture, the architecture, so it's quite, when we use the high availability solution, so it's based on the cluster, Cassandra cluster, it's based on a Redis cluster. So we use for recent data and for internal SquirrelDB synchronization. And you just have a couple of sharding with SquirrelDB servers that are behind the load balancer, so we use Nginx, but that could be anything that's doing load balancing. So we use it in production for a couple of, a bit more than a year now. It's powering our monitoring solution, so it's used by a bit of more than hundreds of customers for us. We provide regular releases on GitHub. We have a Docker container. The project on GitHub has a Docker compose file, so you can start up very quickly. We have the documentation for all configuration and deployment, and we are happy to welcome more users or contributors.
All right. Thank you so much.
Yeah, let's start. Sorry. Okay, so I will tell you about how we are tracking object storage costs. And yeah, first of all, who am I? So my name is Fyodor. I'm a member of Capacity Squad in Grafana Labs. What we are doing, we are keeping an eye on cloud costs. And yeah, it's my first talk on PromCon, so apologize for any issues. So why keeping object storage cost is important for us? Because it's number 2 in our cloud bills, and also depending on the project, we cannot just multiply project spendings by some amount, because it depends on the project. For some projects, it's only 2% of overall cost. For some, it's almost a half. So there are two general ways to how we could measure object storage costs. One is related to using billing tags, but that doesn't give me an opportunity to make a PromCon talk, so we choose the second one. So for all major clouds, there are open source exporters. So they're available on GitHub. They will provide some metrics for you. You just could install them and start using them. But yeah, please remember when you're using for this AVS exporter, there are some caveats about how you will sum metrics. If you have experience with Prometheus, you know about that. But if you don't hit with that issue, so I will show you. So when you just sum two metrics and some of them have undefined values, so you will get the result only on intersection of these values. So there are two ways how you could deal with them. One is using this or on vector 0, and another you could use name as a label and also sum these metrics. So yeah, you will see that will give you a better result. So after that, when we have these metrics, we have to attribute them with teams and namespace. And there is also some feature in PromQL, so you could introduce a new label, new metrics, and pull all textile labels as labels and values with value 1, and after that you could use that join with group right, and yeah, you will extend your original metric with extra labels. So sometimes you don't need to develop some exporter, for example, for these labels, and you could have some very simple exporter, for example, with some Apache or Nginx, and with some static file that will give you enough result. So, yeah, our final goal is to have prices to get final cost. So for final cost, we need to know prices, and prices depends on region, etc. So for that, we internally we drafted some exporter that will query cloud providers' pricing APIs and will export these values as Prometheus metrics. We can use them in our Prometheus queries. So it's still a bit dirty and draft. We're working on them. At some point, we will open source this exporter as well. So yeah, combining all of that, that's just an example how our final query could look like. Actually, it will be 3 times more, because more operations, we should also include storage costs, but all parts will be the same. And yeah, that's it for me. It's lightning talk now. For questions, just reach me out. And yeah, you could reach me out online using these links. Thank you.
Awesome. Thank you. So now we know all the ways to cut costs. Perfect.
Hello, everyone. So I'll be talking about Prometheus-like Grafana data source plugin for Victoria Metrics. For those who are familiar or know what Victoria Metrics is, it can be queried through Grafana using Prometheus data source because it speaks the same language. And many users do that even right now. But at some point, starting from Grafana 8.3, we stumbled upon the issue when user complains that his queries doesn't work anymore. After some investigation, we discovered that Grafana enforced validation of metric names and label names according to Prometheus naming convention. And the queries, users' queries were containing dots in label names, and that stopped working for them. So Grafana rejected those queries even before they were sent to data source. But Victoria Metrics could have been processing them and responding with success. So there was no a quick way to fix that. So that's why we decided to try to fix it in the very easy way, to create our own data source for Grafana, and we called it a data source for Victoria Metrics. And it was designed to just fix only this problem, but we didn't stop with that. And I will show a quick demo. So here's the dashboard we're choosing Victoria Metrics data source, and everything seems very familiar to how Prometheus works. But there are some differences. I will show, for example, how we calculate this graph. So this graph calculates a percentage of memory usage for a specific job. And here's the queries that we use. I don't know if it's too small. OK, so here the query which we use for that. And it's query pretty simple, but still is complicated. So we have this feature called with templates, which allows you to use enhanced version of the PromQL where you can define variables and functions. And I would type this query with you in live here, but I have only one hand free, so I predefined it. So in this with template, I have a filter, which basically captures, applies all the filters by job and instance, the same that we had on the query below. And also, I have a function called ratio, which I defined, which accepts the current metric and the limit of that metric, and calculates the percent usage on the same time interval. So now having this with template, I can do this. And Grafana will suggest me to use this new function, and it shows the description and how it is defined. So I use it, and instead of current, I will pass this metric. And instead of limit, I will pass this metric. And this I can delete. So bam, it works, but it's not the same because we had max by job. So we apply max. Oh, sorry. It's hard to talk with one hand. Yeah, thanks. So yeah, it is now the same. So this is how you can simplify your queries and taking into account like really complex queries that we can have. This could make things better. What also is cool is that we have more complex queries here. So for example, we calculate the amount of time which is left for this for storages to fill up, and it has really complex query here. So it is big. And what we have here, we have a prettify button, which does after formatting of the queries and makes them consistent. What is also cool with this plugin is that it allows you to trace the queries. And trace the queries shows the exactly, like it is very similar to explain analyze in Postgres. So it shows how the query was executed on the backend, and it shows where time was spent, like how many time series were fetched, data samples processed, and all this available in the data source. And you can also copy this JSON and probably send to a friend who can then also try to analyze that and help you with interpreting these results. Yeah, so that's mostly it. I guess maybe these ideas will help in future for Prometheus data source. Yeah, feel free to find me to ask more questions. Thank you.
Thank you. Yeah. I was told 3 times by Kemal on my phone, who is sitting at the registration desk, that there are bagels still available. We don't want to throw away food. I forgot 3 times, so now I'm telling you, there are still bagels, and if you want a bagel, go to the registration booth and get one. Yes, more lightning talks. After the talks? I mean, if you're starving, we had plenty of lunch and whatever, but yeah. Also after the talk.
Hi, I'm Guillaume. I'm a Prometheus operator maintainer, and I will show you my love for additional scrape config. So first, what is Prometheus operator? So Prometheus operator helps in managing your Prometheus installation and your scrape configuration Prometheus rules. So in this case, for example, we have a service with pods, of course, and Prometheus operator will provide you with custom resources to scrape those targets. So for example, we have service monitor for the service, pod monitor for pods, of course, but if you have SNMP exporter, for example, you can use a probe. And using those, you can have multiple teams creating scrape configurations without having to manage the same configurations themselves. But there is one use case where Prometheus operator was falling short, and it is forgot to mention, we are generating the configuration for Prometheus to scrape the targets. So yeah, one way Prometheus operator falls short is if you have a VM, for example, or any other target that is not within Kubernetes, then you can't quite use Prometheus operator to scrape it. So a long time ago, someone that probably nobody knows here added something to Prometheus operator, and that is additional scrape config. So it's a big blob of, big comments, but the gist of it is that it allows you to point to a secret containing an additional scrape configuration. So you can do this, put it in a secret, and then it works. But the problem with it is that there is no validation. So if you make a typo, then it breaks the configuration, parsing, and everything. So it's not great. It helps, but not great. So now we have a way to do it. We create this secret, but another problem with that is that it becomes a bottleneck, because you might have multiple teams trying to add scrape configuration to your Prometheus. So someone identified that in 2019, so a long time ago, and said, we need scrape config CRT. People loved it, well, to our scale, some likes on it. And we finally landed it. So we landed it this year in version 0.65. It took us 4 years to get there, but still. Oh, and by the way, there was a bug, so 0.1 is better. Now it allows us to actually get rid of that secret. And, well, it's still available if you want to use it, of course, but we can use a scrape config and scrape about anything we want outside of Kubernetes using Kubernetes primitives. We added a lot since 65. From 65, we had static file and HTTP, but then we added Kubernetes console, DNS, and the next one that is coming in the next release is EC2. So now if you remember the small trivia we had earlier, we have 27 to cover. So what do we do now? So first, we are going to break kubeprom. So blame him, Pavel. So actually not, but since we have the scrape config now, we can change a bit the way we are deploying Prometheus operator. So the small story is that we are creating a service in kubesystem to access the kubelets. We can replace all that with a scrape config, which is an improvement, but ask him. Then we still have 20 service discoveries to implement. That's a lot. And it goes like, if you need one, create an issue or even create a PR. We are very much looking forward to it. Another one is that now that we have scrape config, we are creating multiple resources that are doing the same thing. So the idea is to refactor, service monitor, probe, and pod monitor into using maybe the logic behind scrape config or reusing scrape config. So yeah, if you want to help, you are welcome to. That's it. So the QR code is how to use the scrape config if you never heard about it. And yeah, we are on all those things. Thank you.
I'm impressed you just already had a picture from earlier today in your slides. Did you just come up with the talk earlier today? Yeah, I did. Okay. All right.
Oh, it's scary up here.
Perfect.
Yeah. So first of all, I want to tell you that this is my 4th time on PromCon, and finally I have the courage of actually, doing one of those, and my notes are missing. Can I have my notes, or maybe just a second? I remember a lot of the stuff, but
okay, then you need to.
Oh yeah.
You need to settings.
Live debugging.
This place. I've done this once or twice to.
Yeah, it shows that I've.
Actually, I might have not. Duh. Sure.
Yeah. Nice. Yeah.
There you go.
Oh, thank you. Lifesaver, really. So, yeah. So my name is Mikhail Mikhailov. I work for MariaDB, the corporation, not the foundation. Those people are the cool ones. We're just making money out of the open source stuff. So yeah, my talk is about remote write. Yesterday there was a lot of talks that included remote write to a certain point, and its inefficiency, let's say, about how it compresses, how it sends a lot of the stuff over the network. And then I remember how we had a lot of issues, really a lot of issues with this one. So yeah, this is our story. And yeah, back at the days when I started working with Prometheus, I remember that remote write was like a no-no. It was not encouraged. It had a lot of issues, and yeah, but then you guys started fixing those, and it became a problem, because really now I don't know how to explain to other teams why they should not use remote write, why it's better to just attach my Thanos sidecar instead. Yeah, so we ended up with a lot of remote writes, and yeah, our environment is big. Yeah, my team is working on this SkySQL project in MariaDB, which is like database as a service platform, and we have a lot of databases with a lot of metrics, like 400 clusters and counting are sending with remote write to multiple monitoring systems. So yeah, we have a lot of those. We have Cortex, Thanos, we have even legacy federated Prometheus, and we are in a process of migrating Cortex to Mimir, but yeah, it's not perfect, and don't ask me why we have those. It's like a mixture of historical reasons, and also like inter-team political stuff. But yeah, the good thing is that at the end of the day, I learned to love them all like they're my children. So yeah, it pains me when I see something like remote write make fun of my children. So yeah, this is like one snippet of my manager, and I particularly like how he phrased it, that 11 months ago, we started cost saving on the Cortex environment, and this somehow triggered like 1,000 US dollars spike in test. And we were like very scared of this because, yeah, first of all, the Thanos environment is actually scraping and monitoring the Cortex environment. Like they have all different purposes, but yeah, this is the case. And due to this change in Cortex, basically we produced super cardinality of metrics. We did a lot of like cutting of metrics, but then again, this produced new time series, and it was in test, right? So no one cares. Thanos was down one day because yeah, it's in test. I looked at it and I was like, this is tomorrow's job. But at the end of the day, this happened, like this spike of in money-wise. And we were scared because this could happen to 400 production clusters as well. So we started investigating, and what we found out was like that, first of all, yeah, we found out that the traffic was going towards Thanos receivers. Also, the biggest question was why only the Cortex Prometheus agents were causing a lot of traffic. And spoiler alert, this was because the older version of Prometheus back then. So yeah, and then we started checking the configurations, and we saw those that you see here, qconfig. There is like min backoff and max backoff, and maybe most of you know what this means, but when there is no endpoint to send to, there is like a queue is filling up, and the queue is trying to get flushed at some intervals, and the maximum interval was 100 milliseconds, which triggered a lot of issues, you know. So first thing we learned was keep your services up to date, because in version 2.38, I think, 28 or I don't know, this was fixed due to a potential DDoS attack, which actually happened to us. Then we started reading the documentation and know your defaults, because those were defaults and now they are not. But this is like 99% of the time this will be okay, but our 1% was very painful. Then we implemented some standard stuff. You can see we overdid it, because now our max backoff is like 5 minutes, not 5 seconds, which is the default. And also have your alerts, because yeah, Prometheus has a metric which tells you if an endpoint is down. So why didn't we have one of those? So this opened a really big Pandora's box, because now we implemented qconfig settings, as you saw. We started filtering, great talk yesterday about that. Then we had rate limits in Thanos only.
You're at time.
Yeah, okay. Then alerts, never mind that. We should also make the traffic private, which is like the first thing we should do. That's all. Thank you very much.
Okay. I didn't know you were at the last slide, but still the time was up. On the other side is the HDMI. Oh, sorry. Yeah. Please pull this. Pull this. Yeah. And then now you can use this. Yeah.
Not mine.
Perfect. This is yours. Should show up in a second. Yes. All right. Yep.
Hello, everybody. I'm CTO of Victoria Metrics, and today I'll talk to you about how to properly visualize histograms, Prometheus histograms. Let's look at what is a histogram in Prometheus. I hope that everybody knows that it's a set of buckets with some value boundaries, and every bucket contains counts the number of values which hit in this bucket. So let's look at Prometheus, how Prometheus visualizes histograms. Let's look at request duration histogram. When you write down this query in Prometheus, you will get this result. And do you think that this result is easier to interpret by humans? I don't think so. Let's switch to graph panel in Prometheus. Probably it will be better. I cannot say anything about the value distribution when I'm looking on this graph. Okay, probably Grafana is better. Let's look what Grafana shows. It shows the same thing, multiple lines, and these lines is hard to interpret by a regular human. What's wrong? Probably we need to switch to heat map panel. Let's switch to heat map panel, and the graph looks not so good yet. Probably we need something else. Yes, we need to change the format of this panel to heat map, from time series to heat map. And still the histogram looks not so good and wrong. And the last thing which we need to set is min step in this panel settings. And eventually we will get something useful and something visually good for a typical human. And we can see that right now that most of the queries time execution is between 1 and 2 milliseconds according to this heat map. And we needed to make multiple non-trivial steps in order to get to this view. And there is a better solution. I forgot about another thing. When you hover some point on this histogram, you'll get this image and some kind of value in this box. But this value has no any sense to typical human. It's just, I don't know what does it mean, 0.140. Everybody knows what this means? I don't think so. And the proper solution is implemented in Vectorimetrics. Vectorimetrics contains user interface, basic user interface, which shows exploring your metrics. And when you enter the query, which returns time series, which forms a histogram, then Vectorimetrics automatically shows you heat map instead of lines which have no any sense to typical humans. And additionally to that, when you hover some point on this graph, you will instantly see the percentage of values which hit this particular box in the histogram. This is much more useful to typical users. So that's it. And I hope that Grafana will learn more from VMUI and implement this in VMUI and Prometheus too.
Thank you. Here's some Prometheus coasters regardless. Simon, yeah. This way? Yeah. I think you're the only one who has it on the left. Okay, and Ali is next. So there you go. Oh, and your clicker.
Yeah. Hello. Okay. So Let me introduce myself. I'm Simon. I'm another Prometheus operator maintainer. So I'm not going to talk about scrape config like Guillaume. I'm going to talk about all the other things that we have on our roadmap and for which we might need your help. The first one is, again, one thing that is a long-standing issue is how do you know that your service monitor or pod monitors are properly picked up by the operator? How do you know how many targets are scraped or not? How many are down, how many are up? So we've got this issue. With Arthur, we might have a plan to work on it in the future, but we really want to see that moving forward. The other thing that we have right now, I think it was implemented by Arthur last year, is the support for the Prometheus agent. Right now, the deployment model is very much like Prometheus server. It runs as a stateful set, which is mostly okay, but we know there are some use cases where people want to run as a daemon set. And we also, we don't have yet a very elaborated way to distribute targets to the agents. So again, look at that issue if you want to. The other one important feature that we are missing, or which is not yet complete, is related to the agent 2, is how we auto-scale the shards. So we can distribute targets across different Prometheus servers right now, but we don't have the full story when it comes to scaling up and also scaling down the shards in your cluster. So we have a few, again, issues related to that. Some are more easy than others, but again, we are not only looking for contributors, but also for users that could guide us and tell us how they want to use a possible feature like that. Another one which is quite recent, we've seen in the last month a few users that requested the ability to enforce some scrape settings. They would typically let their users define service monitors, pod monitors, but they want also to have some guardrails when it comes to the scraping config. Typically, they want to ensure that you are not configuring something crazy like scrape every second your targets, or they want to maybe, in some cases, it was to provision automatically the mutual TLS authentication between Prometheus and the targets, which is notoriously something you don't want your users to be doing manually. So again, a couple of issues that you want to check. And the last item that I choose for that lightning talk is supporting Kubernetes events. Not sure if that person is here in the audience, but again, that's something that the operator doesn't do today, so it's quite hard for users to know how the operator behaves and whether there is some event happening to say that your Prometheus pods get unavailable, then how do you know about it? How, again, do you know when there are errors in the way you define your custom resources? How to get involved? Obviously, we have the usual stuff. We run bi-weekly meetings. Everybody is welcome to attend. If you've got a use case or you're not sure about filing an issue or a feature request, come there. We are nice people, I promise. Yeah, so if you want to look at the slides, just take that QR code, and that should be it. Thank you.
Everybody is excited, so you know what to contribute to next. But there are also Prometheus issues, I assume, not only Prometheus operator ones. Do you have HDMI? Yeah, you need to use this adapter. Yeah, and can you plug this into the HDMI? Yeah. Yeah. Yes, it should show up. Yeah. Yeah. Yep. All right, and all the lightning talk speakers who I forgot to give coasters earlier, please get one at the front desk. Take it away.
Hello, everybody. So it's also first time talking PromCon. I've been here a few times. I'm pretty nervous, but hopefully it went well. So I'm not talking about solutions. I pretty much want to talk about problems. I want to ask more questions to more people, actually, if anyone have the same issues. This is kind of like a POC of like solutions that I have in mind. But before that, I give a bit of an overview. So I work at Trade Republic as a SRE in developer experience team, which what I like the most is, there's nothing that I like more than like consistency, because that would help me to get my work better and help the developers, help the same tooling and everything to give developers like view on that. And so that's like the issue that I was like facing in, I think like last week or something, and I was trying to figure out like how can I solve this issue? So let's jump real quick to the problems. So the problems are related to like alerts. Actually, there's a really great talk from Monica yesterday about the similar things, about analytics of the alerts, which is what I want to do. But let's see like how we do like an alert right now. So we have like multiple teams in the companies. Like it's a pretty wide organizations. We have a lot of service in the clusters. And since I'm talking about consistency, like I want to make sure that like everything have the same like alerts and like metrics and so on. And we have a lot of shared alerts, which I think a lot of people also using like the Prometheus mix-in or something, which is shared alert, which is great. That's just out of the box. You have everything's like alerted. And let's say the grade service is down. We have an alert to alert manager. And this is probably the alert that we see that. So we would be able to see that the pod is actually like a crash loop back, and we see that there's a critical, but we don't really know like who's the owner of this, because this is a shared alert. We couldn't really enforce the labels on the Prometheus rule alerts, because if you enforce, we don't really know which label we should put on the rule itself. And for the routing, it's probably easy. We can just like have a regex that routes to the right channels or something for the teams. But what I'm trying to do is not really for the routing part. What I'm trying to do is to actually try to understand per team, like what's their mean time to recover, what's their mean time between failure for each metrics that, or like each alert that they have. So I was like, and the best metrics that I feel like to get this data is actually from the alerts metrics from Prometheus, which is really nice. You have all of the visibility, when it starts, when it ends. But the things that's missing is the team name, like all of the tag name. That's why I was like calling the talk about like enforcing the rules. So I was like thinking about this for like a few weeks last week, and then I was just like, maybe the easiest way to just write the code. So I write this sidecar. I hate it to have this kind of solutions. That's why I put like the sad emoji there. But pretty much like how it works, I'm just trying to express myself about how it would work. So how it works is pretty much you just have like a sidecar next to the alert manager. It will just receive the request from Prometheus. And I would just have like a simple rules that actually just check like if it's matched these labels, please enforce this label, enforce that label, and so on. So like if you go to here, let's go bigger. So yeah, I put like some of the examples. So the rules is very simple, just like that. It's very readable. I can actually fetch this from service catalog of the team, actually generate it directly to the applications. And I have the magic of the graph right here, as you see here. It just works out of the box. And I feel like we should be able to do this in Prometheus Alert Manager. Maybe I just don't have the knowledge for that. So if anyone knows how to solve this just using the relabeling or something, please let me know. So since I hate sidecar, I think a lot of people probably don't want to add more sidecar. I tried to create a PR in Alert Manager. Maybe I can just attach this simple logic in Alert Manager, which I did. I don't have any tests or anything because I'm expecting anyone to just complain to me, hey, you shouldn't do it. Please do it another way, or like maybe there's a way to do it already. But this PR works. I tested locally. But if anyone can actually like tell me, but the code looks a bit different. So I call it like enforce label rules. It's more like enforcing that we want to have consistency on the label rules on the alerts. And yeah, that's pretty much like the problems and kind of like the solution that I'm trying to like resolve. And I'm looking forward to like simpler, like better solution. Maybe I don't need to do this kind of like sidecar or like some patching on the code. We can have it out of the box. That would be great. But the end goal is just to have consistency on the labels when the alert is actually being hit. And I think that, yeah, pretty much like if there's a better way, please let me know. I'm not really sure, as I said. And yeah, that means thank you. And the other part is like say, it's a Javanese, so you might know how to write Java, but You might not know how to speak Javanese, and you can talk to me in Javanese if you want. But yeah, I'm from Indonesia, and that was me. So yeah, that was all.
Thank you so much. Perfect timing. 0 seconds left, right there on the spot. And there you go. Next speaker lining up. And I also like how you tried to use PromCon as contributor office hours. they happen, so you can also just join those in between PromCons, you know. So should show up there. Yeah, and now it's gonna go live.
Okay, hello everybody. Lies, damn lies, and request time. What's behind this dramatic title? Imagine we have a full REST service that needs to respond under 100 milliseconds. That's an arbitrary service, an arbitrary number is an example, but imagine those 100 milliseconds are our service level objective, because we need this response time, maybe for a real-time application. So we decide to instrument our Go service manually with the Prometheus library. So we wrap the handler between, we count the start time, and then we observe the time of this, of each service request. And to try it, we use Grafana K6 just to add some load to our servers and see how it is behaving. So when we visualize the metrics in Grafana, we can see that the server is performing well. We are under, the percentile 95 is under 100 milliseconds, and the average is also pretty low. So let's see what is saying K6. K6 thinks different. They say that the average request is over 100, and the percentile 95 is almost 3 times our SLO. So what's happening here is Prometheus lying. So basically, just to remind a bit, the life cycle of a service request, we have from the client side, when the service request starts, we have some network time. Then when the request reaches our server, we have some connection time at the kernel side. Then it reaches the Go runtime in that case, and this request is enqueued until it can be finally dispatched. So we are measuring with our manual instrumentation in the code, we are measuring this fragment. And this part, in some congestion scenarios, might be a small part of the total time. So maybe we cannot, we could instrument the client-side applications, so we will get the overall view, but maybe we cannot, because maybe we cannot add telemetry to the client code, or just because we have a public API and we don't control what the invokers do. So couldn't we trace at least this part, the part of the code or the part of the request that is in our server? Yes, we can. Thanks to eBPF, we could insert some probes at the start and the end of the connection. And that is what Grafana Villa does, actually. So if instead of manually instrumenting the server, we use Grafana Villa to provide metrics about the total connection side, we can see that data is much closer to the reality. So for example, the average is near to 100, is not exactly what K6 sees, and also the percentile 95 is near or around 250, which is not, it's maybe 10% error with respect to K6, but it's much closer. basically because the what Grafana Villa is able to collect does not, it doesn't track all the events that can have influence in the final user perception. And that's it. Thank you very much.
Sorry. There you go.
Oh, thank you very much.
Doesn't help, like, typing on the outro slides, not paying attention, sorry. Yes. All right. All right. I want to talk to you about a pretty huge challenge that we're facing as an industry. Actually, it's two challenges. The first one is something that Apple, if you watched the most recent App event, kind of mentioned on the side, but I think it's a pretty big deal, which is we're now at the point where parts of our processors are like 12 silicon atoms wide. So we're starting to hit quite literally the physical limits of what we think is possible with hardware. And even if we don't care about this, we already heard about this yesterday, the carbon footprint of data centers is actually pretty huge, larger than aviation. And so pretty much what we need to do as the software industry, we need to learn how to build and run our software systems in a more efficient way. And one way how we as Polar Signals participate in this is in a live stream that we run every Friday, where we take random open source software and try to optimize it for, to better the world a little bit. And I'm bringing this up because in one particular episode, we actually tried to optimize the node exporter, and actually Matthias did this episode. And it turns out we actually weren't very successful at optimizing the node exporter code itself. It's actually pretty well written. But, and I wanted to show this real quick, what we did find, what we did find is that random collectors that we had enabled on the node exporter were using as much as 7% of the CPU resources, even though this collector is completely useless in our infrastructure, right? And so the point is try to use kind of the insight that we have available, whether it's profiling, whether it's any other kind of technology to help us get insight, but help reduce the cost, the efficiency, and improve the efficiency of running our software so that we can fight against this, push back the physical limits of our hardware further, and reduce the carbon footprint of data centers worldwide. Thank you. That's it. Okay. Thank you for doing a lightning talk on my work. Oh, wait. This is You can have it. I put the coasters on your chair. That was easy enough, sitting next to you. Over there. Willst du den nutzen? Müsste an sein. Du kannst auch hier und dann den Bildschirm benutzen. Ja.
All right. Hello, everybody. I'm Tom, also from Grafana Labs. And we recently ran a performance analysis on the OpenTelemetry collector Prometheus and the Grafana agent in terms of what resources they require to ship metrics they scrape into any remote write compatible backend. And it doesn't work.
Turn it on the side then.
All right. So the setup for that was that we had 10 synthetic load generating targets that we were scraping using once Prometheus, once using OTel call, and once using the Grafana agent. and we were remote writing into a custom remote write receiving binary that was counting how much was ingested so we could actually check they were doing the correct thing. Each of those ran on an M5X large, so there was more resource capacity available than they would require, so we could see what they need without running into limits. And we had an extra Prometheus that was like scraping all of those collectors, so we have those resource informations. Whatever. For the results, they are more or less what we expected. But all the Grafana agent, Prometheus agent, and the full Prometheus use the official scraping implementation present in the well-known Prometheus server. So their numbers are roughly similar. The Prometheus full is the one that's running with the time series database, while the agent is running with the agent flag, which explains the difference in memory because the one has the database, the other does not. And the Grafana agent requires a little extra memory, but not really CPU because it also includes some extra things like built-in exporters. The OpenTelemetry collector is quite high, which is actually expected because it does so much more. Like it is agnostic to formats, includes all of those different input ways, and especially converts data twice in memory, like once at scraping into its internal format and then write again into what it uses for output. However, those still come in quite high with an extra 360% memory and an extra 533% CPU usage. We ran 10 targets with 500K series in total at a 15-second scrape interval, which is admittedly quite large, but we wanted to test limits here. Which raises the question what actually to use when wanting to send metrics from A to B. And from our data, our recommendation is if one is sure that you will only you will scrape open metrics or the Prometheus text format, as it might be known better as, and send it to some Prometheus-compatible destination like Mimir or Thanos, then you should probably use the official Prometheus implementation in whatever distribution works best for you. However, if you are not sure this will actually be or stay your use case and you want various input formats or different destinations or a combination of those, the OpenTelemetry collector does have extensive format support, which is much richer than what Prometheus can offer. However, this does come at a cost for the traditional Prometheus workload. So this is something you have to be aware of. As an extra note here, the Grafana agent already at this day can work with both. So it includes the official Prometheus implementation for the open metrics to remote write path, and also can work with every OTel component out there, and will in the future become a real OTel collector distribution. So you could get the best of both worlds. Thank you.
Don't need to do anything. Sorry.
So, it's already showing the right thing. Oh, thank you. So this is going to be the shortest lightning talk. Of course, as most of you, or at least some of you will know, we have a tradition. Obviously, we have a bit of data at Grafana, and most of this data is highly relevant to the business. So it's usually a little bit secret, but there's one special exception to this, and once a year we show the Prometheus adoption stats. Of course, we can, and we like Prometheus. So without much further ado, this is the number for 2023, and you'll get the new one in 2024. That's it.
Can you take the laptop?
Ach so, der Laptop. Lass ihn. Ist eh nur ein Mac. braucht keine Sau, ist nur ein Mac.
Thank you, Richie. I suppose that was the instances running?
The what?
The instances running?
Grafana instances which have at least one Prometheus data source enabled.
Got it. Nice. There will be 1 million soon. Let's see. You all should contribute to make it happen. Cool. The clicker is dead after 2 days of PromCon. Anyways, so I think, the slide says it all. It's a wrap. Quite literally. No, we had some other stuff. So we gave out coasters, we gave out t-shirts, and as you can see, Kemal is outside, super excited to hand out all the rest of the swag. First come, first serve. If you go outside and get the coasters, the stickers, probably the sponsors have stickers still. We don't want to take any of it back home. It will sit in some basement for who knows how long, like next PromCon worst case. But please take it. It's yours for the taking, and we don't want to store it. Then, Ja, you want to come on stage? Because while you were seeing me on stage and around all of this room, Ja was handling everything else really. She did the entire social event yesterday. I just showed up just like you. I had no idea what was going to happen. It was all Ja. So another big round of applause. And yeah, we have videos on YouTube. Soon. I need some sleep and some rest, and then, eventually they show up as usually. You can find them on the Prometheus YouTube channel, so that's where that will happen. But in the meantime, we had the live stream the entire time, so if you skip through like 8 hours of YouTube videos, you can potentially find the thing already you're looking for, but it's not as polished, obviously, as the other stuff. Which brings me to everybody being excited, hopefully, after 2 days of PromCon. Contribute. You have seen Simon do a bunch of PRs and issues on slide decks. We know everything else from everything Prometheus and its ecosystem. You've heard so much about what you can contribute. It doesn't need to be code. It can be documentation or anything else. You want to mentor, you can ask Bartek, for example. He's always happy to mentor. You can get involved, right? That's the message. You can do that on Prometheus.io/community again. We have everything there, calendar, etc., etc. You can find it. You can join the Prometheus ecosystem called the Bug Scrub. I don't know why I know all of this stuff from the top of my head, but there you go. And then thank you to all the speakers, and I would like to have all of them back on the stage. Did every speaker get their coffee mug? As you can see, everybody should have this cup. We had like 10 cups that weren't this cup shipped to us. I don't know why that happened, but it happened. So if any of you have that cup in the box, tell us and we'll exchange it. Which brings me also to these people have submitted their talks, which was amazing, and it couldn't have been possible without them, obviously. And next year, or any conference, obviously, you want to submit talks, and we can rate them. There's one specific company which might have stood out to you throughout the last couple of days, which has submitted very, very many talks, which is amazing, but we also want everybody else to get a voice in this community, right? So please submit. That is very important for the livelihood of this ecosystem. Then thank you to the Prometheus team and its maintainers, as always, I guess, goes without saying. So yeah. Then thank you to Basti up there. You were doing, big wave. You were doing the live stream. And I heard that like yesterday at some point 50 people additionally watched from somewhere in the world. And I don't know, we don't have the stats right now, but yeah, there were many people watching online who couldn't make it. So that was really great to have. And also the live stream wouldn't have been possible without the camera team, audio, video up there, everybody doing the lights, which are like completely blinding me right now. So that was like really, really cool. I didn't have to do anything. You were a great team. Another round of applause. And additionally, also Radial Systems, everybody else who helped organizing, who connected us with the caterers, etc. I think the food was good. We know we need more food at the first break because everybody gets here hungry in the morning. We took notes, we'll get more food. But I think the lunch was great, at least that's what also everybody told me. And most importantly, next to the speakers, you are the reason we did this, and it was great that you all came from all parts of the world to Berlin to experience the city, to experience PromCon. And yeah, thank you for coming and having a blast with us. And I forgot to thank the sponsors. I didn't put this on the slides. Thank you to all the sponsors, Grafana Labs, CNCF as diamond sponsors. That was a huge help, obviously, so another round of applause for them. And then Red Hat and Ollie, is that how you say it, Ollie? Yes, perfect, I remember that. So huge thanks to them as well. And the final part is, see you next year. Who wants to come back to Berlin? So yeah, we'll do the Prometheus Dev Summit tomorrow. We'll probably, as a first agenda item, discuss kind of a debrief of what happened this year and whether or not like Jar is exhausted enough to do it next year or not. And maybe after one night's sleep, I might do it again. But yeah, maybe we'll see each other back in Berlin. We'll announce it sooner so you can buy tickets and hotels earlier. I know that was a mistake and it took too long, but we learned from many things, and hopefully we can see you in 2024 and make it even better. Thank you all so much. Bye-bye.